of asphalt rubber based on the experience that we've had. So California experience goes back to the 70s. The asphalt rubber was used in chip seal applications and in hot mixes. In the late 1990s, asphalt rubber took off in California. And there was a bill that became a law in California that required the use of rubber up to 35% of the projects. Today, actually, asphalt rubber became a mainstream strategy. That means it is the first strategy you need to consider prior to conventional asphalt. And if you are not going to use asphalt rubber, you have to justify why you're not using asphalt rubber. Here is a visual view of the experience and the various strategies that are main strategies that are used. Chip seal, also called stress-absorbing membrane, and chip seal interlayers. They're called SAMIs, or stress-absorbing membrane interlayers. Basically, chip seals that are placed in between the asphalt layers. Then we have open-graded hot mix, and dense-graded hot mix, and gap-graded hot mix. These are the main strategies. Of course, there are various strategies that are part of these main strategies. Based on a 1977 ADOT, Arizona DOT research report by Green and Tolonel, asphalt rubber can undergo about 5 times the strain before rupture than can asphalt. So this statement is very conservative, in fact, based on the studies and research that we've done. But this is the basis for actually understanding the behavior of asphalt rubber. The elasticity of this material and this product contributes greatly to the successes that we've had in terms of fatigue resistance and reflective cracking resistance. We do have designs based on fatigue and reflective cracking criteria. Reflective cracking is to resist existing cracks when you do an overlay on top of an existing pavement. Based on the research that we've done, typical lab fatigue performance, that's based on the research that we've done in California. The conventional mixes are less fatigued by 10 times, or let's say asphalt rubber is 10 times more than the fatigue resistance of conventional dense-grade AC. 10 times that translated into design standards, into a reduction in thickness that has actually shown excellent performance. We've used reduction of thickness 50%, around 50%, for various strategies that give us equal performance and give us cost-effective product. Here are some of the fatigue testing that we've done on existing pavements. 5-year field aging study using we have 2 binders in California, or asphalt sources. One we call the valley asphalt, which is a hard asphalt, and one we call the coastal asphalt, which is a softer asphalt. The coastal asphalt gives you a more fatigue-resistant product. And so in this study, basically, when you look at the asphalt rubber hot mix gap graded on the right with a valley, which is the stiff asphalt source, you get a fatigue life that is substantially more fatigue resistance than densely graded with valley. And this is densely graded with coastal, which gives a better product than the valley asphalt. So in terms of fatigue curves, we have proven that asphalt rubber will give you a much, much better fatigue-resisting product. It is astonishing sometimes why this product hasn't taken off in some of the states or countries, even though we have a much, much more understanding to the behavior of this material than many other products. In terms of the stiffness ratio, you will see that the asphalt rubber is less stiff, it's more flexible, more pliable, so to speak. And the fatigue ratio is 10 times. That's based on that study. So the fatigue model, where we are going to have a design criteria, we have to limit the compressive strain on top of the subgrade to tolerate level to ensure adequate structural bearing capacity. So that's very important. So if you are designing a pavement structure that is completely made out of asphalt rubber, you need to make sure you have a strong base so that you can resist the rutting parameter in the pavement. And of course, we have to limit the tensile strain below the asphalt rubber and the asphalt layers with the appropriate transfer functions to ensure adequate fatigue life. So these two criteria have to be met to provide a good performing pavement. And these are basics for pavement design. In addition to these two, and many of the pavement design let's say, philosophies in the past did not really look into the reflective cracking criteria. Although in Caltrans, that's the California DOT, there has been a limiting criteria for reflective cracking. So we have to limit the stresses at the crack tips below the overlay to overcome the problem of reflecting cracking. And of course, there's nothing better than asphalt rubber to resist reflective cracking, especially when you are using asphalt rubber interlayers. You dissipate the high stresses, the high stress concentrations at the crack tips. Here is a fatigue model for asphalt rubber, gap graded, and with the transfer function and the HMA, which is densely graded asphalt rubber or hot mix asphalt. This is the design philosophy of asphalt rubber that has been used in California. Reduce thickness by 50% typically compared to conventional pavements, with equal life, even better, that exceeds even that full depth. These are the criteria used in California for design. So asphalt rubber hot mix gap graded in this column, and hot mix asphalt in this column. These are equivalencies. You can see, for example, 60 millimeters of hot mix asphalt is equivalent to 30 millimeters of rubberized hot mix asphalt gap graded. And there are various criteria here. And then you have composite pavements that includes SAMI F or SAMI R, and these are interlayers with fabric or rubberized over hot mix. And these are the equivalent designs. 105 equivalent to 60 millimeters of rubberized hot mix, SAMI-R over 30 millimeters HMA, and so forth. In terms of pavement, we actually cooked this product to death in terms of the studies we've done, in terms of accelerated pavement testing, laboratory testing, and field performance. All of the three components of research and investigation we've done. And based on other work also, for example, the ALF, which is the Accelerated Load Facility at Turner Fairbank Highway Research Center. They've done test sections comparing asphalt rubber, as you can see, asphalt rubber versus SBS polymer versus control. With the number of passes, asphalt rubber behaved amazingly in terms of performance. Whereas you see the control failed very quickly. The SBS also failed. However, the asphalt rubber sections did not even show any failure till many, many cycles. This slide George showed, these are the studies. For example, this is the Arizona type 1 asphalt rubber versus various types. You have a control section, and you have SBS, you have terminal blend. There is no comparison. These are heavy vehicle simulator that we've done. These are Caltrans studies that were done in South Africa prior to purchasing the heavy vehicle simulator that we have in California, 2 machines to do simulations. So prior to purchasing those, we wanted to actually validate our guidelines that we were already using. And this is a validation study that showed the asphalt rubber hot mix gap graded at 25 millimeters versus 38 millimeters and versus 75 millimeters of conventional asphalt. You can see that both reduced thicknesses, even 25 millimeters, performed better than the 75 millimeter conventional asphalt concrete. Another study by the heavy vehicle simulator in California, UC study in 2004-2007, also validated the same thing. As I said, we've cooked it to death. There's nothing we can do more. So the pavement strategies that we've utilized for two aspects, one in pavement preservation and one in pavement rehabilitation. So we do have a program called the Pavement Preservation Program, which is basically you need to preserve your pavements, the integrity of the pavements prior to the need for rehabilitation, so you can extend pavement life. That's the whole idea of pavement preservation. You need to preserve the pavement and keep its integrity so it can last longer and you can extend its life. So pavement preservation is a strategy that has to be utilized by all transportation departments. You cannot wait until the pavement cracks and then you do rehabilitation. That's very expensive. So you need to do the preservation ahead of time. So preservation, you look at good pavements, between 5 and 10% cracking, no more, okay? And they have to be in a good condition. This is a proactive approach. So in this proactive approach, we've utilized rubberized strategies. Thin overlays, 50% of the program that we have for pavement preservation are thin overlays, like 1/10 of a foot, which is kind of like 1.5 inches, let's say. And seal coats are like chip seals. We use 50%. And pavement rehabilitation, that is when you're doing a structural design for your pavement. That means your pavement has more than 30% cracking and requires now for you to step in and do more aggressive measures so that you can actually bring your pavement into a new condition, a new structure, so that you can start from new. Of course, this is more expensive than the proactive pavement preservation. So you look at structural deficiency, which is high deflections. That means you'll be using falling weight deflectometer or other devices to measure deflections, and you will have a criteria about the deflections. And based on deflections, it will be what is the thickness of your overlay. And reflective cracking criteria. So you may have low deflections. So you go and actually hit the pavement with the falling weight deflectometer, and you have low deflection, but you still have cracking. This is a reflective cracking phenomena, and you need to design for reflective cracking. So for reflective cracking, we've utilized asphalt rubber interlayers. They are called, in some of the agencies in California, ARAMI, asphalt rubber aggregate membrane interlayer, and SAMI-R, which is stress absorbing membrane interlayer. They're the same thing. But if you are using the same term without the word interlayer at the end, that is like a chip seal, basically. In California design, ARAMI or SAMI, that interlayer is equivalent to 30 to 45 millimeters of hot mix asphalt. So it can actually, you can reduce the thickness when you are using a SAMI, an interlayer, by 30 to 45 millimeter, depending on the base type. So for a base type that is very rigid, it's going to be 30 millimeters. For a base type that's more flexible, will be 45. Here is just a schematic view of how a SAMI looks like below the overlay. And here's the cracked pavement, which has low deflections. So we're using an interlayer, and we're putting an overlay on top of it. This is a reflective cracking design. Various types of strategies that have been used. There's a system called composite layering system. System 1, let's call it here, Cape Seal. It's a slurry seal over ARAM, which is that interlayer we talked about. It's a chip seal. So that's called a Cape Seal. System 2, Cape Seal, slurry seal over ARAM over leveling course. So when you have a situation where you have to level the pavement, and so you have a good surface to put your overlay or the chip seal, we call it a leveling course. And system 3, overlay over ARAM over leveling course. So basically, this is a system for resisting reflective cracking. It's an overlay where the other system did not have the overlay. They had the chip seal only and a slurry seal. So many of the cities and counties, they try to use the lower cost strategies. And system 4 is asphalt rubber overlay over ARAM, which is the interlayer. So the quality of the asphalt rubber chip seals is amazing. We've done a lot of evaluations of asphalt rubber chip seals in California, and even after 10, 15, even 20 years, you can still pull the chip seal and it's still elastic. That elasticity is what gives the product the performance. Here how it looks like if you pull it, and you can see the elasticity visually 10 years later in this picture. This is why it provides that thickness equivalencies, because these chip seals or interlayers dissipate the stresses at the tips of the cracks. That's all we need to do, is dissipate those stresses and put the overlay on top of them. This is actually a study we've done with George Pais here in Portugal, evaluating the interlayers. And you can see the interlayer here being modeled and how the interlayer is dissipating the stresses. I would say these red spots, we call them the hot spots. This is where the stress is at the tips of the cracks. By providing an interlayer, you completely dissipated the stresses, and your overlay is not really resisting these high stresses. Here is an example of an asphalt rubber chip seal that we described earlier in Norwalk in California. 19 years later, it still was performing excellent compared to what it was prior to this strategy. And another way we want to look at, not all asphalt rubber products are equal. If you saw how the Turner Fairbank Highway Research Center, the ALF study that I discussed earlier, and that showed how SBS was behaving like a polymer modified asphalt. It did provide better performance than conventional, but the asphalt rubber binder itself way surpassed all of the other products. In terms of viscosity, the Thermal Blend is much less viscous. As I said, it is more like a polymer modified asphalt. So the Thermal Blend is, on the average, over 36 times less than the viscosity for asphalt rubber at 375. Lower viscosity means less binder used. And if you are using less binder, that means you're automatically and logically, you're going to have less fatigue life. It is that high binder content, plus the elasticity, of course, that gives you that substantial improvement in fatigue life. So we've done other work outside California with the asphalt rubber successfully in countries where actually did not have experience in this product. So this study that was done by Thodison in 2009 that talks about the percent recovery, asphalt rubber and polymer modified products, SBS, EVA, and you can see the difference between them. Asphalt rubber has the highest recovery. This is another way to look at it. So you can see visually the highest recovery compared to all the other polymer modification. And so in terms of climatic conditions, we use the base asphalt for the asphalt rubber, PG6416. In all climatic regions, we use the same base asphalt, okay? We don't want it to be a stiff asphalt, so it is moderate climate asphalt, even in the desert region. Whereas the PG grading for HMA, you're going to be using sometimes 70, PG 70-10. In the desert, typically C70-10. We've done also a life cycle cost analysis using Federal Highway Administration real cost software and user's manual, and Caltrans life cycle cost analysis procedures manual. And we basically took a segment, 2-mile segment, with a DT of 150,000 both directions. And we have an existing pavement, 150 millimeter distressed flexible pavement over an untreated aggregate base. And the cracks were over 3 millimeters. The rehabilitation design, 20-year service life based on reflective crack retardation. Remember I told you this is one of the criteria we use when you have low deflection. But you have cracks, you still have to overlay. So strategy one that you would typically use in this situation, a conventional hot mix asphalt, 155 millimeter overlay. Strategy two will be 60 millimeter conventional HMA over SAMI or ARAMI, that is the interlayer. So you can reduce the thickness because we talked about there are thickness equivalencies if you are using a SAMI. 45 millimeters equivalent. So 105 minus 45 is 60. Strategy 3, 60 millimeters of asphalt rubber overlay. So a 60 millimeter, okay, is equivalent for asphalt rubber is equivalent to 105 millimeter conventional hot mix overlay. That's how we would design it. All of these strategies are different alternatives for the same design. And strategy 4 will be 30 millimeters asphalt rubber overlay over a SAMI. We integrated all the user costs and agency costs. And net present value, discount rate 4%. The analysis period, initial construction, first rehabilitation, second rehabilitation. User cost and agency costs incorporated into the analysis. And based on the net present value, we have this comparison. So we're going to look at the total costs for the various strategies. You can see if you are using just a hot mix overlay, 4,352 here. And if we look at the lowest one, that will give you 2,525. So it's a big difference in terms of cost effectiveness. These are equivalent lives. So it's plain and simple. Strategies that use asphalt rubber interlayers are the more cost effective than those without. So interlayers are very important. The benefit of asphalt rubber interlayers is substantial, no question about it. equivalencies of 30 millimeters to 45 millimeters for interlayers seem to be conservative even. And we're talking about asphalt rubber strategies that we've used based on the wet process. I don't know how many of you are familiar incorporating the asphalt rubber through a wet process in the tank of the asphalt and heating it to a minimum 45 minutes. We're not talking about even other products that are much, much superior, like what we talk about George's presentation about RAR-X, for example, and how much, and the fact that you can incorporate even way more than what we can incorporate. We're using about 18% rubber into the asphalt rubber binder. Asphalt rubber strategies are more cost-effective, proven, than conventional hot mix asphalt. This is life cycle cost analysis, so you can see the numbers. But based on field performance, we have seen it. This is just to demonstrate to you that this product is a cost-effective product based on actual life cycle cost analysis. So strategies that use a combination of asphalt rubber overlays and asphalt rubber interlayers are the most cost-effective strategies. Strategy 4 that we discussed has the lowest net present value. So reduced thickness of asphalt rubber is a reality backed by extensive experience. Reduced thickness design standards are being used on many roads with great success. The reduced thickness standards can be applied to both structural and reflective cracking design, provided that there is adequate pavement support. Minimize the compressive strain on top of the subgrade, and that the fatigue and reflective cracking criteria are satisfied. So I was pleased to hear that in Poland, actually, they did a complete pavement from all the different asphalt layers using asphalt rubber. That's amazing. So that's another success story there. So we're saying, yes, you can use it for structural and reflective cracking design. Because some people may say, you only can use it for reflective cracking overlays, or just overlay designs, or just pavement preservation. But it can, provided that you need to provide a strong base so that you can satisfy all the pavement design criteria that is intuitive. Thank you.
Shakar, excellent presentation. Can you go to that last table where you have the cost? Oh, that one. Okay. Now, maybe my eyes are not seeing very well, but it looks like strategy 4 costs less. It's about half of the strategy 1, right? 4,500, 2,000.
Yes.
Yeah. All right. These are facts. You have seen it. You are the chief pavement engineer. You know now that California is using these technologies.
Yes.
Why do you think that other states are not doing this? Why do you think that other countries are not doing this? Why do you think that in Portugal, that we have been talking about it for 500 years, these numbers don't seem to penetrate, don't have SAMIs?
Well, based on my experience in California, the implementation process of the new products and strategies, sometimes you get resistance even from industry, competing industries. Not only the political level, sometimes they don't want to rock the boat, so to speak. They want to create problems for themselves, pressures from industries that are already benefiting from the marketplace, and they don't want to share the market. So they do put a lot of pressure, and we've experienced that a lot in California till today. I mean, it is hard even to implement another new strategy without going through all of the stresses and pressures coming out of certain industries. They don't want to compete and share the market. That's one. The other is actually you need to have people who can become leaders that will have to fight for it. It doesn't come easy within the agency itself. Mm-hmm. Somebody needs to assume that leadership role and push it all the way through the system. And I would say probably in many states, they're afraid, many countries, they're afraid to use a product that will compete with an existing product. As you can see, many of the positions are political in agencies. Mm-hmm. And people like just to, live a simple life. Yeah.
Okay, thank you for your response. That explains a lot.
Yeah.
Any questions? Yes, please.
I noticed in California, as in Arizona, we have covered up concrete pavements with asphalt rubber. Maybe I missed it there, but I have a feeling they do this in California. We have a little bit different criteria in that, can they hear me okay? Talk slower. Oh, closer. It's closer to the phone.
Raise it up.
Closer to the phone, huh? Okay, all right. All right, very good. In Arizona, we are limited by the curb height, structure height, ramps, and so forth. So a lot of people who have more control of this than I had would say no more than 50 millimeters, let's say 2 inches. And we went down to 1 inch, just 1 inch open graded. Is there some similar type of thinking in Caltrans, in California, that you have a limitation on what you can do, and it works beautifully on concrete, but is there also the other limitation of these other things that you can't really ever do 4-inch overlay of anything, or 2-inch, more than 2-inch, because of all these other restrictions?
We've had similar experiences. We've done long life pavement strategies in California. When we came under the structures, the bridges, because of clearance issues, we had to dig down and do reconstruction for those long pavement strategies. Sometimes you are limited when it comes to structures based on the clearances that we have. We have covered some concrete pavements with asphalt and asphalt rubber in many locations. Sometimes it wasn't even necessary, but they've done it.
Yes, and do you do more open graded over concrete, or do you do like more gap graded over concrete?
More gap graded, but we've done open graded on top of the gap graded.
Okay.
Yeah.
Thank you.
You're welcome.
Let me get my other job.
You have a question? It's nice to ask questions, huh?
I love that one.
Well, Shekhar, really very interesting presentation. Thank you for that. My question is this. So for this strategy you're talking about, I think one of the things you mentioned earlier on was the crack percentage. For example, less than 20% or less than 30%. What is the percentage of cracking you are talking about for this example here? Let's assume it's 20%. If it's not 20%, let's say it's 40%. What's your strategy look like? Is there any thought on those things?
Yeah, then if we have extensive cracking, we'll have to cold plane remove part of the layer, and over 30% is still rehabilitation. Yeah, rehabilitation overlay, unless of course the pavement is completely destroyed and then you have to do reconstruction.
Okay, well, the reason I check that is, for example, in state of Michigan, for the state routes or federal routes, so if the crack percentage is less than 20%, we're okay with it. We just let it go. 20% is above 20%, then that's cause some kind of concern. Usually it's smaller, just, we just ignore it. That's usually what the practice in Michigan look like. But because cracks happen, all the time.
Yes.
Well, okay.
Take a chocolate.
Thank you.
Thank you.
I have a question regarding course materials. You mentioned that you are building a 30 millimeter wearing course, and you also have performed tests on 25 millimeter wearing course. What size of aggregates do you use in your asphalt mixtures? And where do you use it? For example, there are different climate conditions, and if it works in more hot areas like in Africa, and if it works well in, let's say, in Norway, where the temperature goes below 0 degrees Celsius.
You mean asphalt rubber strategies? Of course, paving has to be in a certain window of the year when it's warm, okay, but it should perform very well, even in colder climates, because we've done it in various, we have in California actually 6 climatic regions. And so we've done these strategies in various areas.
And what about the sizes of course material?
The size, normally we use 19 millimeter maximum size aggregate. Sometimes we use 12.5 millimeter maximum size aggregate.
Yeah. Thank you very much.
Thank you.
Any questions? So, thank you, Mr. Sturchat.
Thank you.
The next presentation is by Alexander Zorovsky. A long life pavement with rubber modified asphalt binder, a case study of the text section on the X19 expressway.
Good afternoon. My name is Alexander Zborowski, and thank you very much for invitation. This is actually the second time I can attend and present something on the rubber asphalt conferences. Last time it was almost 20 years ago in Palm Springs. I think it was 2006. And I'm very happy I can present today the topic. Thank you very much, Dr. Shatnafi, for introducing the topic. This is about this what the doctor was saying at the end, the perpetual pavement made and built solely with rubber asphalt. And the other authors of this of the presentation and the article are also Igor Rutmar, Karolina Pełczyńska, Agata Grajewska, and Sebastian Kopytko. General concept for extension of the durability of flexible pavements. Just for comparison, traditional asphalt pavement, we know this very well, and it's really pity to say, but if we look at the pavement cross-section and the parameters that each layer has, the mixtures, we need to notice that the asphalt base course is actually the weakest mixture of all the structure from the flexural stiffness, flexural fatigue life. This is the worst mixture to withstand cracking. Has the lowest amount of binder, the highest gradation, the highest amount of air voids. This is actually the recipe for start cracking here. any other layer, binder course or wearing course, is much more cracking resistant. But that's the tradition. That's how, for many years, we've been building. There was a question about, from Dr. Sousa, why nobody wants to change anything? Because nobody wants to risk anything. They have their position, they want to keep it. That's the tradition. Nobody can blame them that they took the risk and suddenly it didn't work. You know very well there were many technologies, many materials that didn't perform as they were promised. So, you know, people from the administration point of view, you know, on the side, they are very careful. They are afraid to burn. And I think the lack of knowledge on their side, of experience, these are the main problems. Going back to the comparison between the traditional versus perpetual asphalt pavement. And on the right-hand side, you can see the perpetual pavement, where the best, and I think the most expensive layer is on the bottom. This is the elastic course, significantly much thinner than in the traditional. Why? Because it has a lower stiffness moduli, has more binder, less air voids, and in traditional way, we can say about the perpetual pavement that there is any tradition, you use a ridge bottom layer here. So I would say slightly over bitumed mixture with a little more asphalt, like 0.5% more binder than normally, lower air voids, etc. The way that we did in Poland and in Europe, we are also using highly modified, polymer modified binders here. Not the regular polymers, but the HIMA, with much higher binder content, with less air voids, better compaction, thinner layer, which allows us for better compaction. This very thick asphalt base in the traditional pavement also doesn't help that it's so thick. There is always much higher air voids level here at the bottom than at the top or somewhere in the middle. So this is the comparison. We put a lot of attention on this bottom layer because, why? Because that's the point where the highest tensile stresses are. So the layer here should be most fatigue resistance from all of the layers. Then we have this very thick and significantly higher stiffness modulus mixture here. Okay, long life pavement design methodology adopted in Poland. To properly calculate this, we examined a lot of different methodologies, including the MEPDG and Ashtower, but it looks like from all of the studies that the French catalog criterion was the best suited for this. Although it is a mechanistic empirical method, but with a lot of empiricality inside, because in France they did a lot of studies on the trial sections, and they developed a lot of empirical calibration coefficients between different types of mixtures. So this is a really good criterion for this perpetual pavement. And for probably the most important factor is that it introduces into the criterion directly epsilon 6, so the fatigue life criterion for the mixture, which no other methodology we found has this. And for the permanent deformation, we use the regular Asphalt Institute criterion. Development of long life pavements in Poland. Between 2015 2019, we constructed two types of pavement. First was flexible perpetual pavement on section of S8. It was finished in 2015. This was the first in Poland and one of the first in Europe perpetual pavements with this anti-fatigue layer with a very elastic polygon binder. It was something, we would say, it was a grandfather of the HIMA at this time. The HIMA was not present, commercially not available, but the polygon had very good properties. And it was also the high stiffness modulus binder course, also made with the polymer, of course, the polymer in the surface layer, and it was also very characteristic at this time, because this was the only pavement, at least in Poland, built solely with polymer-modified binders, top to the bottom, all 3 layers with PMB, and the bottom, as I said, with the highly modified asphalt. And then there was a requirement from the private contractor, Lotos Refinery, for a heavy-duty pavement, only 20 centimeters we could use for this, and it had to withstand really huge loads, industrial loads inside. This was not the public road, this was industrial road inside the Lotos Refinery, Project EFRA, efficient refinery. And as you can see, the pavement is made of 3 SMA layers with very gradation of the aggregate, 16, 22, and 16, and highly modified asphalt in all 3 layers. And it was also a very successful project. After a few years, because the cross sections and the pavements were presented in Euroasphalt, Euro Bitumen on this EAPA conferences, EAPA, European Asphalt Pavement Association, introduced these solutions to their technical review about the high-performance asphalt pavements. And this both solution, you can see here, this is this flexible perpetual pavement with this highly modified asphalt on the bottom. And this is what we call the triple SMA or 4 SMA pavement from the Lotos. And it was introduced as the recommended high-performance pavements. Then we constructed another 6 of this type of the pavement sections, 4 in Poland and 2 in Hungary. And at the same time, we are working on rubber asphalt modification using the wet method. The very traditional, actually the method that we use was very close, if not exactly this what the California is using. Not the California, I'm sorry, Arizona is using, but we ask for the equipment that also allowed us to do the California method. So using also not only regular rubber powder, but also the high natural rubber and extender oil. So we can actually do both methodologies, but we've been doing the regular Arizona method. We called our product Rubber Bead. It always sounds better if you have some nice name for your product on the commercial scale. So there was a small competition and one of the colleagues won with the Rubber Bead. I really like the name. So this is basically this rubber modified binder. And we did our introduction of the rubber asphalt through the research project financed by the European Union and with cooperation with the Warsaw University of Technology. It took us 3 years to master the technology. Here are pictures from the 4 pavement structures with 6 different layers, 6 different mixes constructed in front of the headquarters of Strabag in Poland. And this was the trial section done in 2013. 12 years later, this pavement is still in great shape, all 4 sections. And the traffic on this pavement increased like 4 times because we have a huge logistics center. The fields you see here, there are 4 of logistic centers. One of them is the biggest in Poland. So the traffic really proved the concept and the materials we were using. We have 2 professional machines, the DNH, with the performance of 25 tons per hour. As I said, they are actually, they are ready to produce the asphalt rubber also with Californian method. The hopper is divided. Here is the section for the high natural rubber. We can use also the regular rubber and the extended oils. The most important applications of this rubber bead, first of all, they were used as the exchange for polymer modified binders in the wearing course only. That's what the market asked for, also because due to our catalog of typical structures, we are obligated to use the polymer modified binders only in the wearing course, not in the binder on the base course. So it would be hard to prove the cost efficiency if we use this everywhere, just like this. This is actually the picture from the biggest project that we did with this, with the rubber bead motorway A2, 17 kilometers of one of the most trafficked sections of the motorways in Poland. Very busy. The project was done because we needed to widen the pavement and add the third layer to this. In total, we did 28 contracts since 2013 to 2023, and we use approximately 250,000 tons of HMA. Looking at the total amount that we are using, this is not too much because this is less than 4% of our total production. So we really could do much more, but we are constantly talking about this. There are some problems, mainly administrative problems, lack of standards, norms for this type of materials. But we are still working on this and hoping that it's going to be better. For this 250,000 tons, we used 162,000 tires. So it's always nice to look how many tires were not burnt in the cement factories, for example, or waste otherwise, but we use them, recycle them in a really good way. Asphalt rubber, the optimal binder for durable, long life pavement layers. After this mastering these two methods, technologies, perpetual pavements with polymers and rubber asphalt production, we did a lot of studies and further research on the rubber asphalt. We didn't stop on the standard technologies. We went into the higher modification, like I said, the California method. But instead of the high natural rubber, we start using also different small amounts of polymers, block polymers, together with the rubber, different extender oils. We were actually able to get binders that were twice as good as the Schema, the famous Schema. But it's, again, right now we are still struggling with the standard rubber asphalt. So I hope there will be a time when we will be able to utilize also this hybrid rubber asphalt, polymer rubber asphalt. So why I think that this is most optimal binder for the perpetual pavement, long lasting. First of all, high elastic relaxation. This is the rubber modified binder, and it's not fast speed. This is just the looped. We have 35% of the rebound. Regular polymer only 24%, and the HEMA has 30%. So even comparing to HEMA, we have a higher relaxation of RMB. Here are the results from the DSR, dynamic shearometer, the last test. And this is the regular binder, neat asphalt. This is the polymer, regular polymer. This is HEMA, and this is the asphalt rubber. And again, the proof that really this material has extreme elastic properties. And last but not least, the high viscosity, which really help us to keep the binder with a much thicker than normal binders film thickness. And this is very important. We know this from the porous asphalt, yes, that it's really necessary to have this thick thickness, but it's also important for this anti-fatigue layer on the bottom. So we decided to connect these two technologies and use the synergy of connecting the long-lasting pavement, perpetual flexible pavement, and the rubber-modified binder, using the higher quality of the quality control, higher quality of the laboratory test and field test. So the full RMB pavement concept was created. And then we start looking where we can use it. And first we really hoped for a big section that was at the time start being built, and it was 26 kilometers of the S19 section of the expressway called Via Carpatia. It was finally built in 2021, only 400-meter section. That's what our client allow us for this. We are really grateful to our administration that from there it was really needed a lot of strength and hope. So we are really thankful for them. This Via Carpatia is very important from the strategic point of view. I think you might see this from maybe some news. This is the Rzeszów, very important NATO hub for the communication with Ukraine and Lublin, which is now, the airport was moved to Lublin because the Rzeszów airport was so badly damaged for this extensive usage of heavy transportation, the heaviest airplanes, that it need to be rehabilitated, so it moved to Lublin. So there is extremely high traffic here now, and we built this 1 year before the war started. So now it's almost like the ALF, accelerated load facility on this section being done because the traffic is 3 to 4 times higher than it was actually predicted. Pavement structure, I said we used advanced lab and field tests, including the Fourier transformation, infrared spectroscopy, dynamic sheriometer for the G-star, MSCR, and LAST test, and also the dynamic stiffness modulus and SV-ECD test. And for the field test, we use the PQI for better control of the compaction and also the layer thickness, non-destructive layer thickness using the MITSCAN T2. Master curves for the pavement structural design. This is the master curve for the anti-fatigue layer, significantly low stiffness. This is the master curve for the for the binder cores, the highest stiffness modulus of 3 of them, and this is here the SMA from the wearing cores. So as we can see, the anti-fatigue has a lower stiffness, is more elastic than even the SMA. Resistance to fatigue. This is the comparison of this anti-fatigue, AF11 asphalt rubber mixture, and the traditional normal mixture, asphalt concrete 22 millimeters maximum gradation that would be normally used. And we need to remember this is the logarithmic scale, so it's twice as much fatigue resistance than normally. So here is the pavement design, the structure. 4 centimeters, I'm finishing this, I'm almost at the end. 4 centimeters of the wearing cores, 13 centimeters binder cores, 8 centimeters of the anti-fatigue layer, thicker by 3 centimeters unbound granular base, edge, and also a few lower pavement layers with much higher bearing capacity than normally, also using the cement stabilized base courses. So basically much more stable foundation for this significantly more elastic and resilient asphalt layers. And this is the standard pavement that was built on the other part of this section, this S19 section. As I told you, this was only 400 meters. Experimental section, the rest of the pavement was built the standard way. And this full RMB pavement has calculated 96 millions of ESOLs, and the standard only 52. A few pictures from the construction. This is the asphalt mixing plant with the asphalt rubber modification machine, the DNH machine. The binder properties obtained during the production, dynamic viscosity, 3,200 millipascal seconds, RNB softening point 66, Celsius degree, resilience 35%, and con penetration 41. On the right-hand side, we see the requirements. They are similar to this, what is used in the United States. A few pictures from the pavement construction process. As we can see, something that is still worrying us, unfortunately, higher temperature of the production, 10 to 15 Celsius degree, higher temperature that we need to handle this high viscosity binder, but this is something that we are right now working on. And I know that after my presentation, there should be good presentation about lowering the temperatures of rubber asphalt, so I really hope for this. Conclusions. Pavement with extended durability, as I said, 96 millions instead of 52. Thicker unbound granular base, greater usage of local materials, stronger foundation for asphalt layers, anti-fatigue layer, higher elasticity, and increased fatigue resistance, 10 times bigger than comparing to the regular mixture. And then the wearing cores, increased bearing capacity of the layer. This was actually the hardest to do because it's really hard to obtain the layer and the material that is from one side has a good stiffness, because that's what is required from this very thick layer to give the good bearing capacity, but at the same time it's using very elastic rubber asphalt. So we started with the Bailey method to obtain the good skeleton, very well interlocked skeleton, aggregate skeleton, and then we added the rubber to also have a proper cracking resistance. And then the SMA 11 with rubber asphalt increased resistance to low temperature cracking. I'm sorry, I forget to translate this from Polish to English. AMG, it's asphalt modyfikowany gumą. This is in Polish, the RMB. I'm sorry for forgetting to translate this. So good resistance to low temperature cracking, skid resistance, lower noise. Durable, functional, and ecological full RMB pavement, 85% more durable, and at the same time, 6% lower initial cost. Why? Because we saved 3 centimeters comparing to the standard. And in the standard, you didn't have so many modified layers. So we have fully modified asphalt pavement, which behaves much better, and is even from the initial, not only life cycle cost analysis. I will show next slide. These are 2 last slides, yes. But even in the initial cost, it's 6% lower. Life cycle cost benefits, but you need to understand this is from year 2019, so all the costs are completely changed from this time because of the war in Ukraine. So, and this is assuming the length of the entire 26 kilometer section, not this 400 meters, but the whole 26 kilometers. So it would be 350 million, so a little less than $100 million during this 50 years of exploitation, potential profit for investor on this 26 kilometers. So I think it's a significant saving. And the slide about the carbon footprint doesn't matter after today's presentation of the life cycle assessment. I think it doesn't matter. Anyway, we've been doing this estimation based on really incomplete and unverified data. Everything changed because we didn't have this exact data about the rubber powder, so now it doesn't matter. So we have the effective, ecological, and economical solution that now it's almost 5th year, it will be soon, and we see it performs really great with, as I said, 4 times higher traffic than normal. So I would assume you have almost like 8 to 10 years normal traffic, and behaves very well. Thank you very much, and have a question.
Any questions? No? So, please.
Did you do some actually storage stability testing? I mean, the problem with actually modified rubber binders is that there are some problem of phase separation. I mean, they say that some sludge will be formed, and so I saw that you have done a lot of work, and probably you did something in industry. So did you use some additive for that, or did you do something to prevent that? And the second question is that whether you have performed elastic recovery testing too. Actually, my question is a little bit general. You see, for polymer modified binder testing, there are several tests that have been recommended. Can the rubber modified binders meet those specifications? I mean, can they pass those testing too?
So answering from the first question, yes, storage stability can be a problem for rubber asphalt, hot-wet method, but that's why we are using I showed this machine from DNH that is connected right to the mixing plant. We are blending, reacting for 45 minutes, and immediately using the rubber. We don't store it for overnight or I don't know how many hours, so there is no time for sedimentation. If you would like to transport this with tanks without agitation, anything, then there would be a problem. But that's why this equipment needs to be attached to the mixing plant, which can be sometimes a problem because you might not have so many machines if you have many mixing plants. So And then the second question was about
Elastic recovery test.
elastic recovery test. Of course, normally, of course, we do the in ductilometer, we do the ductility test. And we tried this with rubber asphalt. It completely doesn't work because you cannot even extend this to this 40 centimeters, it breaks. But from the other point of view, have you ever seen a crack in the pavement that would be 40 centimeters, wide? So this is not, it's more like the index. It's not a real performance test. And this test that I show you with the ball is actually used for the hot melt sealants, used for repairing the cracks. When you have 15–17% of the polymers and you have this high viscosity. Why? Because the rubber asphalt, which in my opinion is really great, is closer to the hot melt sealants than the regular binders, which are like a water almost. So yes, it's, maybe this was, but I think it's still good comparison because this test shows a good elastic parameters for all of the mixture, all of the types of them. And ductilometer is really good for the polymers that are very well dispersed. If you have the separate granules of rubber, it really doesn't work, and I think it shouldn't even work. As I said, it's not visible. Okay. Thank you very much.
So next presentation is Ana Rodrigues Alosa. And the presentation is, the subject is environmental benefits of a cleaner engineered asphalt pavement, technology incorporating recycled tire barrel, and the warm mix additives. Sorry for the...
¿Sí? ¿Yo? ¿Yo? Vale. So, good afternoon, everyone, and thank you for being here, and especially thank you to the organization of this conference, to George, which I had the chance to know in South Africa, and of course, Jorge. For the ones who doesn't know me, I will briefly present myself. I'm an assistant professor at the University of La Laguna. La Laguna is at the Canary Islands. And before, I was working with Professor Juan Gallego, as some of you may know, as he has been working many years with rubber. I've been working 15 years, but many of you have much more experience because, as Jorge said, here are the best of the best. Today, I'm going to present you something that I consider important because we speak about sustainability very often, but we have to prove it. If something is sustainable, you have to tell me why and then how much, right? And then I will believe you. This morning, we had a nice presentation about the climate pressures, how important it is. This expert from New Zealand explained it very well, and as you know, it's very important. And even if you don't believe in climate change, political pressures are there, so we have to do something about it. So we all know we have to reduce greenhouse emissions and also minimize energy use, which signifies also a cost, conserve raw materials, and promote recycling. Okay, we know that road construction can be energy intensive and can contribute to greenhouse emissions, especially because we use bitumen, and it comes from oil, right? And a very innovative material or technique that we have is rubber, of course, but also if we use warm mix asphalt additive, we have the benefits of rubber that we all know, plus we can produce it at lower temperatures at the asphalt plant with all the benefits that it means. So this is more research. Answer the question of which are the environmental benefits of incorporating recycled tire rubber, asphalt rubber, and warm asphalt additives. So the research of the objective of this research has been the following. We're going to compare a traditional road, which is made of hot mix asphalt, and we're going to compare it with one with rubber plus warm mix asphalt additives. And we have compared very similar sections, okay? The one on the left is made with traditional, conventional temperatures. And the one on the right, only the surface layers are made with rubber, warm mix asphalt additive, and it's produced at 100 degrees, and the rest is the same. So we're going to compare it. The methodology. To some of you is familiar, to some of you not so much. I will explain it briefly. There are 4 stages. The first one is the goal and scope definition. So basically, a life cycle assessment, you can make it of anything like a phone, glass of water, any service, any product. In this case, the product is a road, right? Then, on the second phase, we have the inventory analysis. Okay, this is the data we're going to use. And it's important that it's accurate data that you can trust. And sometimes this type of data is not available because it belongs to the companies. It's not easy to find. And some other data you have it because there are databases like EcoInvent that maybe you have heard before. It's from Switzerland. The third stage will be the impact assessment, in which you say which are the environmental impacts. And then you have to make an interpretation, which is what we're going to do in this case. For this research, we have used EcoInvent and other data that are not available to people in general. And it's a cradle to gate. It means that we have considered materials, its transportation, the production of the asphalt, the construction of the road, the maintenance operations, and the end of life of this product, which is the road, which in this case is the demolition of the road. Here's the hypothesis we have used. First, the functional unit is something you have to define in this type of research. Is a square meter of payment per year of service. Why? I mean, you can have 2 lines, you can have 30 kilometers, 200 kilometers, you don't know, but you know 1 square meter. And it's very important to introduce a year of service, because as you know, I usually use this very silly example. You might buy a sweater that is very low cost, and you're going to use it just for 2 years, because after 2 years in the laundry machine is destroyed. Or you can buy a more expensive one made of, I don't know, alpaca or made of a very fine thing, but it's going to last more. So who is buying cheaper? The one who is investing more initially, but it's going to last longer. So durability is an important issue here. The hypothesis that we have used, which I would love to discuss with you after, is the following. We know that the roads that incorporate rubber, they last longer, for sure. This is something we don't need to prove anymore. And the hypothesis has been 10 more years, but it's based in other papers, one of them of a Portuguese researcher, Picado Santos, that some of you may know, professor. So for the conventional row, it lasts 20 years. About the 8th year, we're going to make the surface treatment, some milling, recycling, and demolition. And for the road with rubber, just milling and demolition. We don't need so many maintenance operations. But as I say, this is an hypothesis, and we can make another study with another hypothesis. But for sure, the road with rubber is going to last longer. In this, I think we all agree. So the results. If I would like you to remember just one data from my presentation will be that if someone asks you, next time they ask you, okay, roads with rubber are sustainable, but how much? You can say that over its life cycle, more than 15%. More than 50%. And here are the results. The last one is climate change, but we also have ozone depletion, ionizing, photochemical, ozone formation. Also, if we worry about cancer, we know if it's toxic or not, acidification. We have even land use. There are 16 different categories. It's true that the one we care more about because of climate change is CO2 equivalent emissions, but we have other categories. If we compare the two roads only by what we say stages, construction, the slurry, the milling, the recycling, demolition, here are the results. We can say, well, in red we have construction. It's predominant in both cases. So that means that when we use bitumen and aggregates, it has more impact than maybe milling. But depending on the impact category, demolition can be a lot. It depends on the category. But if we just see the first one, which is climate change, we will say construction, recycling it impacts as well, and a bit of demolition. So we have to think about how to reduce the impacts when we construct the roads. If we compare the results only by material or process, it means which is the responsible of more impacts. Is bitumen, is gravel, is rubber? Rubber, for sure, no. It's in yellow there. You cannot see any yellow in the second. Well, the first one, it doesn't have rubber, but the bright yellow, you don't see it. So if you put rubber, it doesn't matter at all. If you consider its life cycle. Bitumen has an important role, but also transport. See the first CC means climate change. There's a lot of transport when we build the roads to take the materials, to transport them, but we're also considering the upstream's impacts, right? This is what a life cycle assessment does, in fact. So bitumen is important, especially see on the second results, ozone depletion. This is due to bitumen production. And not electricity, the prime and task coating, not very important. So maybe bitumen, I would say. But it will take you some time to decide for you, I mean, to take a look, depending on each different category, which is more important, but climate change, the use of diesel during the life of the road is in kind of orange, yellow. That's even more than bitumen. The green transport, I would say, is even more than bitumen. Anyway, we have to replace as much as possible with rubber the content of bitumen. So the conclusions, very brief. For all categories, if we use rubber and we produce the asphalt at lower temperatures using wire mix asphalt additives, we can reduce the impacts by 45 until 16% compared to a conventional road. And that's a lot. Why we have these benefits? Lower production temperatures, yes, but mainly because if we use rubber, the lifespan is going to be longer, at least 10 more years if we use rubber, and also the maintaining operations are going to be less. This both means less impacts during its life. It's a cradle-to-gate LCA that, as I said, is since the road is born until it dies. Cradle-to-gate is what it means. So this technology is sustainable. We have proven it. It promotes circular economy. We are going to conserve resources, enhance pavement durability, because it's also important that it's better for climate change that we have lower emissions, but we also need a product that has a good performance. But this is being proven over the years with rubber. And we can have low-carbon infrastructure with rubber and wire mix asphalt additive without compromising the performance. I will be glad to answer any question that you may have. Thank you.
Any questions?
Hello, Professor. This is Gangadhar from India. A very interesting and thoughtful presentation.
Thank you.
May I know about the type of Warmix additive that is used for the research?
The type of?
Warmix additive.
Yes, yes. As you may know, we have organic, chemicals. It could be also a foaming one. And it has been chosen a chemical one.
Okay.
A chemical one because it's like an intermediate. If you use water, there is no impact about the wire mix asphalt because it's, I mean, there is no additive, it's just water. It's a foam. And organic, one of the very popular wire mix asphalt is a Fischer-Tropsch wax, and it comes from the oil industry. So it's better like a chemical.
So in the LCA process, most of the time, the temperature reduction that is obtained will be counterbalanced by the raw material extraction when we produce or develop these Warmix additives. So in the LCA process, did you consider the raw material extraction phase of the additive?
Which phase?
Raw material extraction while developing the additive.
Okay, one second, because which extraction do you want me to?
Raw materials like Warmix additive, suppose asobate, organic or chemical additive. While you producing or developing the additive in the industry or something, so you need to extract the raw materials and develop the additive. So that phase has some emissions. That is generally more than the reduction that is obtained from the
Yes, I would say a few things about it because it's not the first study I make about it. It's published, a study that I made with the University of Sydney in Australia, and there I consider a Fischer-Tropsch wax. As I said in the presentation, they're not very transparent with which is the carbon footprint of each additive.
Yeah.
And that's true. But let's say we consider different additives and all of them have different carbon footprints. Because we are considering from the construction until the end, adding that additive, even if the carbon footprint itself alone, let's say it's quite high or something, during the lifetime, it's nothing.
Fine.
You know?
I agree. Yeah.
So, and so also people used to say, but what about rubber? Because you put rubber and, oh, you need to shred it before and make it into powder. So this has been considered. And you cannot see it in the impacts. Is neglectable? What's the negligible? What's the word in English? Yes. Negligible. So it's, and that's a good thing about this type of study because some people can ask you stuff about rubber, like to make it negative. It's not that green, but it is.
Yeah.
And only with science and studies we can prove it.
Yeah. Thank you.
Thank you very much for your, yes. You forgot the chocolate. It's, I think, chocolate.
Thank you very much for very interesting presentation. I have one question. As you know, rubber increasing the viscosity, yeah, very high, and you're talking about that you're doing rubber asphalt plus warm mix. So can you give us factual, practical data, how much you're reducing, how much temperature you can reduce, and it also in the workability, how it's look like on the site.
Yes.
So compaction between where. You
Yes.
understand what I mean? Yeah?
Absolutely, I can give you the
So
there are many,
what is
there are many studies.
production data and the data for the construction? Can you give us, please?
Yes, I totally understand your question. My PhD was about this. It was about rubber, but 20%, which was like a lot, and organic additives. And this has been my work for many years. So it was produced at 180 degrees, and we were able to reduce it 30 degrees. We studied different properties. Maybe water sensitivity was the worst one, but fatigue was the same with organic additives. Stiffness was a little bit more, but also depending on the temperature. And the rest was improving. So I would say, except for the water sensitivity, you can reduce from 180 to 150. That means 30 degrees.
Okay, and on the site?
On the site. As far as I know, and I have read articles and so on, it's the same. It's the same.
Same as usual asphalt?
Same as laboratory.
135?
Yeah, like 30 degrees. There is also another project that I have done with Universidad de Granada. And we were able to reduce temperatures more than 20 degrees, 30 degrees. And in that project, it was a laboratory study, the replication in the asphalt plant, and then we put it. We made it. And because you're asking me this, I would like to say that, well, this has been done in Spain, in the mainland, but I told you I'm from the Canary Islands. With the collaboration of the government, of course, they asked the experts, let's say, we want to introduce seriously rubber, wire mix asphalt additives, these new technologies. We are in the next to the laboratory stage, but the thing, okay, why the Canary Islands is different from Spain? Because we have volcanic aggregates. So we have to adapt our technology to something, because the aggregates are acid, they're strong, but they're not very homogeneous. It's a bit particular, but we want to introduce that. So good news.
Thank you.
Good news.
Be quick, please. Be quick, please.
Okay, thank you. Thank you for your presentation. Only one question that I have. I have more, but
but later we can.
Well, we can discuss a little bit. You presented two variables: chrome rubber plus wire mix asphalt, and you say that you have a reduction of between 45 and 60% in terms of global reduction of characterization impacts.
Yes.
But what is the contribution of chrome rubber? And what is the contribution of wire mix asphalt? Because you are changing two variables.
Yes.
It's important to understand, to clarify the contribution of chrome rubber plus the contribution of wire mix asphalt. Because wire mix asphalt, I think I have a huge contribution.
I mean,
thank you.
For example, because there are other studies that can only focus on the production. Only. Yes, you forgot the chocolate. So listen, when we take a look at this, we have put the wire mix asphalt additive, which is a general chemical, and also the rubber. As I said, is the bright yellow. You cannot see it there. The contribution is absolutely, because as I said in the presentation, some people question that, but it's absolutely nothing. Why? Because what I have taken into account only is to to shred it and to transport it to the asphalt plant, because it's a disposal is in the landfill. It's nothing, and the data is good. You know why? Because Cygnus, and this is what I was saying, that it's important that you have data that you trust. I have the data of 5 different plants in Spain. And I took the number, the medium one. This is the data that is not available to the public, and that is important, and it's from Cygnus, which is one of the sponsors.
I'm sorry, Anna, but we are very delayed. Okay, all right.
Okay.
Thank you.
And it's nothing. Rubber doesn't contribute.
Okay, thank you. Okay.
So
the next presentation is Jorge Pais and Jorge Sousa. And the title is the other page. Design of pavement reinforcement for correct reflections.
Okay. Thank you, Mr. Chairman. Good afternoon to everyone. It's a pleasure for me to be here and to know a lot of very good friends, Josué, Shakir. I think it's your first time here in Portugal, and so on. So this presentation, name is Design of Pavement Reinforcement for Correct Reflection, is the development. Sorry? Okay. Is the presentation of a pavement design method developed by Josh Susan and myself. We started 2000, 2001, 2002, and the things that we are presenting here also the first step that carry out for the improvement is the new approach that we did for this matter. So we are talking about pavement design for asphalt rubber, and the main application of the asphalt rubber hot mix is not for the construction of new pavements, is mainly for the rehabilitation of pavement and the rehabilitation of cracked pavement. So when we are talking about a method for design of road pavement with asphalt rubber, we must think about the pavement rehabilitation, not the construction of new pavements. So we developed for the first version of the method in between 2000 and 2002, mainly because at that time the design of the pavement overlays, not construction of pavement, design of pavement overlays was based on that rule that Shakir presented, where we designed the pavement for a typical situation without any cracks, and if you put asphalt rubber, we must reduce, or we can reduce the thickness to 50%, something like that. So at that time, Arizona Department of Transportation had no design method for this type of situation, and we are contracted to develop that method to try to solve situations like this one. So in 19th, a lot of trial sections were carried out with the application of asphalt rubber hot mix. This is one of the famous one. This is in US, in Los Angeles, something between the city center and the Hollywood. So as you can see, it was a complete cracked pavement, and that was rehabilitated with asphalt rubber. And that part with the black color is the rehabilitation of asphalt rubber hot mix. This is conventional mix, and the other part of the boulevard was also constructed and rehabilitated with conventional mix. So this is a photo from 1990, and some years of service of this road, the aspect was something like that. The trial section with conventional, with the asphalt rubber hot mix remained completely uncracked, and the other one complete cracked. And 6 years later, in 1996, the part with the asphalt rubber remained completely intact, the other one completely cracked. And this is a picture that I took last year from Google Earth in same position, that where you can see the situation 25 years or 35 years later, and you can see that the pavement remained completely cracked. The zone rehabilitated with the conventional mix, and the part with the asphalt rubber hot mix are almost perfect after 35 years. Okay, so in US they had a lot of experience with asphalt rubber, mainly in trial seconds. So it was necessary to develop a method to design this type overlays. And we are talking about, we are talking about something like this one. So we have a correct payment. We must design an overlay thickness to resist to these cracks. So this was another target section in I-14, close to Phoenix, where they proved the performance, the structural performance of this type of mixes. At that time, Arizona was almost covered with the asphalt rubber mix, as you can see, these red lines. So this was the present situation for design of reinforcements when we use asphalt rubber. So as you can see, and also Shaka present, we can reduce the thickness of the overlay to 50%, something like that. So we are contracted to develop a method, and we designed or develop a mechanistic empirical method like a PDG or other mechanistic empirical method that is based on something like that. We have a payment structure. We apply a load to the traffic, calculate stress and strain, apply fatigue loss, and we have payment life. So we did the same, but with a little difference. And difference is due to the crack. So the method is not for design of a new payment, it is for design of the payment overlay or payment rehabilitation, and the old payment has cracks. So these cracks produce a stress, and mainly a stress concentration on the overlay that is responsible for the cracking propagation from the old pavement to new one. So the classical approach cannot be used for this case. What we did, we use finite elements where we can model cracks. So this is a payment, a crack payment, where we put a crack. And the first step for develop was to validate this model. So we did a lot of tests. Mainly, we evaluate in the model and also in the pavement how the pavement moves when a load passes. We measure it with the correct activity. This the one that I have in my university, and we install it in the pavement, and when the load passes, we measure the movements of the pavement. We did it in Portugal. This is in IP5 road in Portugal. We did the same in US, in Arizona. Department of Transportation parking lot, and I-40, and so on, and we measure the movements of the pavement, and we validate this model. So the model that we develop with finite elements can measure or can be used to evaluate the movements that we have in the pavement. So far so good. So the next step was to put an overlay on this pavement. So we have the same model, and we did the overlay. So the next step was the validation of this model. So we did the same. We went to the pavement and measured the movements of the pavement when a load passed. So at that time, we construct or we overlay a trial section in Portugal. We put some blocks of wood to have access to all the cracks that exist in all the pavements. So after that, we remove the blocks of wood, and in this case, we measure the movements not with the crack activity meter, but with the sensors of volume weight, because the main movements that are responsible for the crack propagation are the vertical ones. So we can move these movements like this one, or as you can see in these figures. So we carry out measurements in Portugal, also in Arizona Department of Transportation parking lot. So there they have a complete crack pavement. We rehabilitate it, but before the rehabilitation, we identify all the cracks and measure the movements before the overlay. We apply an overlay with different thickness from this part, starting in 5 centimeters and in 15 centimeters. And after that, we core the pavement in exact position where we identify the cracks before overlay. So this is the overlay. This is all the pavement, and here you can see the crack. And we enter there. We measure the vertical movement and compare to the compared to the one predicted by the model, and everything worked perfect. So at that time, we had a model that can predict exactly what we have in the pavement. So I can say the last step for the pavement design is to have a fatigue law to predict the pavement life. So for fatigue law, we can evaluate it with a lot of tests. So we decide after a lot of approach to use the 4-point bending beam fatigue test to evaluate the resistance. So we did tests with we do two types of mix. The objective of this work was to develop a pavement design method for asphalt rubber mixes and compared to the conventional mix. So we evaluate fatigue life for conventional and for asphalt rubber. And after that, we evaluate. In the previous slides, we are talking about the fatigue life that we measure in the laboratory, but it's different from the one that we have in pavement, because in pavement we have change in material, change in traffic, in temperature, and so on. It is necessary to calibrate these values. We calibrate it using a database from Arizona Department of Transportation, California Department of Transportation, where they have all data from pavement evaluation. So it was a huge spreadsheet with all information for different type of pavement configuration in terms of cracking label, and that allow us to develop the method. The method, we put it in an Excel spreadsheet where the data for design is this type of data. The percentage of crack that we want at the end of pavement life, information about the pavement temperature, the characterization of the existing pavement in terms of thickness and stiffness, and the results are this one. So if you have the traffic label, when you cross the green line, you have the thickness required for the pavement overlay. When you cross this one, this yellow or something, brown, you have the thickness of the pavement with the conventional mix. So that was the 2002 version, and at this moment, we know that we have different type of asphalt rubber mix, mainly with engineering rubber, for example, RAR, that have long fatigue life. And as you can see, conventional mix, something like here, this is the old asphalt rubber and one are this one. So we decided to open, before, the 2002 version was close to the mixes that we developed during that project. So we decided to open to this type of mixes, and due to the long fatigue life that this type of mix has, we decided to input the fatigue law based on slope of the law that we defined by 5, and the number and 500, that is the fatigue life for 500 microstrain tensile strain. And the final result is this Excel, where this first part is existing payment, and here are the 4 asphalt mix that we put in this method, the old one or the previous one, and the new one defined by its stiffness, evaluated with 4-point bending fatigue test, and the N500. And if you have the traffic level, you can cross these lines and you have the payment life. So software is open for everything. Call us, text us, or email us, and you can have access to this one. Thank you.
I have a suggestion. We're going to have questions for him with a gin tonic or some nice drink we have there for him, okay? Because it's time to go for the break.
Okay. Thank you anyway.
Yeah, look at the time.
Costa, não é? Design pavement. Onde é que está o dele? Qual é a dele?
Como é que o gajo me deu? Quantitative assessment. Olha, ver alguém online agora? Vai agora.
Vai, eu não te passei.
Ah, aquela password pequenina, ainda não mudaram?
Olha,
Diz. E bem, este pessoal tem aqui uns problemas com...
It's competing with the cellulose fibers, right? It's cheaper. Yeah, because the textile is cheaper. And does it require a lot of equipment to produce? Full production? You have a machine. No, I mean, if we have the textile, clean textile, to make that into smart product, does it take a lot of machine?
Hello.
Yeah, hello.
Para a esquerda, né? Yeah. Okay.
Okay.
Yeah, and then the document.
Fernanda was. We don't have the document here, Andre. Hi, it's Ricardo.
What? Okay,
Ricardo. The PowerPoint. We are going to copy it to the computer. Just a second, okay?
Okay.
But, podemos abrir outro só para experimentar. Que...
We are going to open another one.
Pois, eu agora tenho que vir aqui, tenho que vir aqui.
Dia 14.
Hã?
Não dá para puxar para aí?
Dia 14. Tarde, o que é que está para aí?
Автоматизовать, это будет дизастер.
Which one is? Which is the file?
16? Não, mas é um qualquer. Pode ser este. Ok, e agora fazemos partilha. Não, temos que fazer ao contrário. É ao contrário. Este tem. Desculpa.
But if you have any production partners in Germany, or no, but if you have, you can consider textile from the beginning. Yes, because you can cooperate with the partners. That's good. Normally,
Okay, I see. Okay. I see it. The sound is good?
The sound is good.
Okay.
The sound is good.
Your voice, a imagem dele é suposto estar.
We are not seeing your face.
You have to connect your camera because we can't see you.
Isto não está como... não está.
Agora está.
Não.
Now we can see you. Não está? Não, porque agora tem que se mudar aqui, calma.
Não, agora temos... Não, aqui como?
Ok. Aqui, carregar aqui em cima. E agora?
Ok, já está. Deixa eu ver se funciona com a coisa.
Funciona.
Yeah? Ok.
Okay, Andre, you're perfect.
Okay.
So if you can...
Ontem foi mais fácil.
Can you see the presentation?
I see the presentation very well.
Okay, so you have to tell me when I have to change, so I can change the slide to your presentation, okay?
Okay, I would say next slide, please.
Okay. That's good, that's good.
It's very positive. Okay.
Do you want to see the room?
First you will show my face or not?
Yeah.
On the screen.
Your face will be always on, and you can see the audience also. Can you see the audience?
Yes.
Okay, I see the audience.
Não, desculpa. Aquilo das posições. Tens as posições gravadas.
Mas queres...
É só para...
Your connection is...
Please speak again, so that we can hear you.
Yeah. I would like to speak like it is. That's this volume, it's okay.
Okay, it's okay. Start your presentation so if we can see that your voice is okay or if it fails.
Okay, I'll start. Good afternoon, ladies and gentlemen. Very nice to see you on the 25th University of the RAR conference. And it's, let me talk about the property of the RAR here. We'll start. Okay, let me introduce myself. That's why I'm starting to work together with George Souza approximately 20 years ago, let's say, or no, 15 years ago. And then we're working hard and make your first RAR. Next slide, please. Okay. Here we are talking about activated rubber. We are not talking about the normal rubber. And that's a lot to say about it. That's a lot of words was said before. Everything is very positive about to use activated rubber instead of the normal rubber. For me, I only want to add that it's very rare synergy of the inactivated rubber that's environmental friendly and economically effective. It's very rare position. But what we need, and very many times...
Andre, it's perfect. So we can hear you perfectly, we can see you perfectly, so it's very good, okay?
So let's say like this. The people are at the coffee break. Let's see if they came back.
George is coming, he will speak to you. Aí no microfone ele deu.
Hey, Andre, how are you doing?
Já está a ficar sem rede.
Not good connection, my friend.
Não, estava ótimo até você chegar. Você chegou, estragou. Você chegou, estragou.
Okay.
Hello.
Agora de cabeça tem que ir ver. Colômbia. É o... Botaço? Não. Quem é o da Colômbia? Diga-me o nome, pode ser.
Mas primeiro...
Não tenho aqui, tenho que ir ali.
Depois quando ele pensou...
Ricardo, vê aí aqui que eu tenho que ir ali com o engenheiro.
Está bem. Olha... Can you hear me?
I'm not...
Is there, I think you have poor network connection where you are, or there is some kind of interference.
I'll try.
Isto é assim. Ele agora saiu. Dá para pôr em espelho. Em espelho? Não, a gente já tentou isso. Vamos ver. It's not very good yet.
It's worse.
It's worse. Do you have a Wi-Fi connection? You are using Wi-Fi connection or mobile operator connection? If you can try switching the network on the mobile by disconnecting the Wi-Fi, for instance, and using mobile data, we can see if it improves. It could be a Wi-Fi problem. Eu vou tentar ligar por WhatsApp. Não. Pois estava. Eu vou ligar por WhatsApp. Hi, Andre. It's getting worse, the connection. It's become. Listen, I want to try something. You have the Wi-Fi connection open on your mobile phone? Can you disconnect it, disable the Wi-Fi, and see if with the mobile operator it works better? Okay, please. And I'm going to disconnect the call so that you have all the bandwidth, okay? I'm going to disconnect. Bye-bye. Não, eu pedi ele agora para... A gente tem que estar aqui.
Mas tu achas que tem problemas? Eu cheguei aqui e faço assim.
Pronto. Much better. Much better. So keep using the network of the mobile operator, okay? No Wi-Fi. You look better. Já foi outra vez.
Android, can you talk to us?
Não, já foi a vida.
Já está a mexer. Ele não deve ouvir-nos. Ele não deve estar a ouvir-nos.
Can you hear us?
Hello?
Andrew?
Carrega lá no 2.
Yeah, I'm hearing you.
Great, okay.
Carrega lá no 2.
It looks like working good.
O Wi-Fi de casa é que devia estar com interferência, ele está a usar a rede do ISP do telemóvel.
Ok. Vês? 2 está no micro.
It works good. Ok.
Já está.
Não, mas isso foi ele. Let's keep this network, okay? This one opened. You can see me, right?
Yeah, I can see you.
Great. So it's perfect now. So let's keep this connection.
Yep.
Keep, the rest of the conferences are in coffee break. They are almost finishing, so maybe 5-10 minutes. But we can keep the connection open. Fernanda is here. She will change the slide every time you need to switch the slide. So I think we're good.
Okay, okay.
I'm here.
Yeah.
I will be changing the slides for you, and I control the camera that we are rotating to our audience. Or this is the microphone of anyone who wants to make questions.
Okay, thank you.
See you. Bye-bye, Andre. Bye-bye.
Bye. Bye-bye. Yeah, and that's Ricardo.
Yes.
Let's talk after this one. Okay, how it will be. Okay, no problem.
After this, okay, no problem, no problem. Okay.
Have a coffee break. Don't forget about the chocolate.
Okay, okay.
So I'll go and take a coffee and come back, okay?
Please, Fernando, please enjoy the coffee.
Okay, thank you.
Oh, Margarida, realmente tens razão. Há ali 2 colunas a falar.
Mas pois, já falámos com os senhores aqui das salas, eles disseram isso.
Já está? Tá bem.
Porque isto é uma ligação com a Rússia e estamos aqui a...
Isto está online, é? Eles vão estar online?
Ele já está online, sim.
Ah, é, está bem, está bem.
Eu enviei-lhe por
e-mail?
o seu e-mail as
Eu vi.
apresentações. Ok.
Eu vi. E aí eu vou usar o telemóvel para pôr aquela Hello, can we start? I think so. Hello, good afternoon to everyone. My name is Jorge Pais from University of Minho here in Portugal. I'm going to share this last section of the day where we have 5 papers, okay? The first one, the title is this one, Quantitative Assessment of the Activation Degree of the Carbon Rubber Surface-Based Gel-Solid Analysis, which will be presented by Andrei Vorobiev, I think I spell correct the name, from Russia. It is online, okay? So please, Andrei, you have 15 minutes for your presentation, okay? Go ahead.
Thank you. Good afternoon, ladies and gentlemen. Thank you very much.
I'm sorry, Andrei. Your connection just failed a little bit. It was good. Something happened.
What?
Andrei, are you listening to me? Andrei? Could you start again, because we can hear you. Hello, Andrei, are you there?
Peraí. Eu tenho que admitir outra vez ali.
Okay.
Okay, Andrei, please start again because I think your connection failed.
Okay.
Engenheiro Jorge, quer apresentar? Porque acho que o Andrei estava tudo bem, mas agora está aqui com problema.
Andrei, we cannot hear you. Maybe we can make the presentation for you here. It doesn't move.
Está aqui.
Pode-se tentar fazer.
Está bem, só se quiser.
Diz para desligar o.
Andrei, please disconnect your image and just sound so we can hear you. Maybe that will work. Estava tudo bem?
Pois está.
Okay. Andrei. Hello, Andrei. Make a video of you making the presentation like you saw Kevin Trenberg doing it, and tomorrow we present it, okay? You see, he cannot hear you. Or I made the presentation. Well, I don't know anything about this, but... No. Okay, we do this tomorrow, Andrei. Sorry.
Now you're hearing me?
Yes. Now it's better, yes.
Okay, great. Let me do that. I think that I should to change. Okay, one moment.
Okay, stay like this, just do it.
Yeah, okay, I will do it.
Move
Sorry, connection, yeah.
Okay.
Okay, I will start and making it small quickly and more effective, I think. Okay, that's next slide, please. Okay, we are talking. We are started working with George Stuzer, let's say 15 years ago, with the activated rubber. The first deal was to increase the quantity of the rubber inside the asphalt mix, and it's why inside the bitumen. But then it's going further. And now we can say that crumb rubber, it's totally different with activated crumb rubber. Activated crumb rubber, this is a new era in the road construction, what we can say. I repeat even his picture in this way. That's a lot of words say about how it's good, activated rubber. What I can say only, this is a very rare synergy of the environmental friendly and economically effective. It's very rare. Please, next slide. Okay, but what we need now, there is a big question that's mostly everybody said. We need some kind of the standards. We should definitely understood that activated rubber, it's not the same as a rubber. This is a difference between like a yogurt and milk. We say that everything is produced from the milk, yes, but it's totally different product. And my question was how to understand this is activated rubber or a simple crumb rubber. And this is now, it's very important because we need now activated rubber certification. We need special for activated rubber asphalt mix specification. We need binder specification. Only what I know, there is the one specification was made in Portugal, and it was great. And this specification was based on a George Souza method, how to check this is a rubber on the upside on the, you see, simple rubber or activated rubber. And this is what shows the viscosity after 90 minutes in a solution in a bitumen. It should be not more than 1.5 times the viscosity after 5 minutes mix. This is everything what we got now. How to determine, how to check. We got activated rubber or not activated rubber. Next slide, please. Okay. Also, of course, we can check in laboratory that's in a microscope. And you see on the left side, it's a closed material, it's a crumb rubber. On the right side, it's an open material. The surface area of the activated crumb rubber, it's increased like 20 times. Of course, it's obviously in a microscope. Next slide, please. Also, we can use the fluorescence microscopy method. And you see activated crumb rubber in 90 minutes became totally without any spots. And that crumb rubber got a spot because its crumb rubber cannot be dissolved in a bitumen. And activated rubber can be dissolved in a bitumen. And this is a main idea why we should put in a asphalt mix not rubber but activated rubber. This is activated rubber, it's prepared, it became friendly with the bitumen, and it's possible to dissolve inside the bitumen. What we know about the rubber, crumb rubber and bitumen? All of these stuff, it's connected with a colloid chemical. Next slide, please. This is a rubber on the left-hand side, and this is more or less activated crumb rubber, more down. How a colloidal chemical said about it? This is consist Zoll and Gel. It's a chemical ideas. In a pure synthetic or natural rubber, like a base of the rubber, it's a pure Zoll. When we put a sulfur, it's became gel inside. What we know, the behavior of the rubber, not a simple caoutchouc. and activate it. While we activated rubber, we should as I know, that's to destroy, let's say, destroy the parts of the sulfur connection. In this case, that's Zol, it's a, let's say, liquid part. It's a liquid part of the rubber, and also it's a liquid part of the chrome rubber. Definitely, the Zol in as a liquid part, let's say liquid part, connected with a bituminous, that's liquid part. No, it's a gel part, and there's some oils inside the colloid bitumen. Bitumen is also colloid. This is why it's so important. Now I gave you that's very shortly basic ideas about what does it mean Zol and what does it mean gel, because it's the George Souza, he's genius, and as everything genius, he said the first we invented something and then try to understand what we invented, to research how we can to check. Okay, next slide please. This is what we can see. That's on the left side, the Zol, only 10%. It means inside the rubber, this is a 10% of Zol and 90% of gel. This is why it's needs for the tires to drive the cars, to keep the cars. But this, as we know, the rubber cannot be dissolved in bitumen. But when we make activated rubber, the amount of the liquid material, the Zol materials inside the rubber, that's already broken the chains of the sulfur chains inside, increase. And this is why with the activated rubber, we got less we got so good synergy activated rubber with the bitumen, because its dynamic viscosity it became more lower. Okay, next slide please. And how to determine, how we can check inside the activated rubber or simple rubber that's amount of the Zol gel. We should to find out something without microscope, even without bitumen, to check. And this is a working of the Soclet apparatus. The Soclet apparatus is not very big deal. It's some kind of the glass that can be cyclic steam extraction. And when we put the samples, you see the samples inside, then they put the toluol inside, toluol, and it's in several stages. While the liquid became totally white, then we understood that's totally the Zol, it means the liquid part of the activated rubber or rubber, totally dissolved in toluol. This is how we make instruction. Next slide. Okay, that's as I said, this apparatus is very effective, very old, and as a quite cheap, and it's no need the special people to do with this. Totally, that needs about 5 hours. For the good materials, for the good activation materials. And here we can see the amount of the Zol that came out, we can see what level of the activation we got in the activated rubber. Next slide, please. It's a very simple process. The first we are making the material, let's say activated rubber, dry, then put in a Soclet apparatus that's doing like several hours inside the extraction, then dry again, and then make a calculation. It's not very hard. Next slide, please. Okay, the first, visuality we see when we should to stop. When the liquid inside became transparent, then we stop. Of course, a very raw checking. If the time to become transparent instruction less than 2 hours, we can stop it. It's not activated rubber, it's a crumb rubber. It's very simple to check in. Next slide, please. But after that, we can calculate what amount for the Zoll inside the activated rubber. Zoll is a liquid part, and this is a long chain molecules of the basic caoutchouc. A long chain, and this is Zoll connected with the Zoll inside the bitumen. Dramatically improve the quality of the Zoll. If we say for this, like that's what a net bitumen inside itself, and making the and gel, of course. I saw one slide of the George Souza gel. It's some kind of the sprinkle inside. It's a structure, and this is making. This is what makes the fatigue, but plasticity. And the quality of this plasticity, this is Zoll. And Zoll gave the really low viscosity. It's not a rubber. It's definitely already not a rubber. It's totally another material. Please, next slide. This is Zoll gel inside the bitumen, the normal bitumen. It's approximately ratio 25-75. And this is how we determine it. We say if a Zoll gel inside activated rubber close to 25%, from 10% in the normal rubber, in activated it can be 25% or even 30%, then the same ratio already in a bitumen we will keep, but with a strong long chain molecules. The Zoll gel became very strong sprinkle the structure of the rubber, and this is totally will be the different mix. I think that's a mix of the rubber and bitumen, and activated rubber is bitumen. It's a totally different materials, and we see this in dynamic viscosity first, and in all other behaviors that I no need to repeat. That's the plasticity, reflective correction, fatigue resistant. This is connected, but it should to be in a correct ratio inside. So it's improved temperature.
Andrei, we stopped hearing you. Tava quase agora. Andrei, the connection is lost.
Okay.
Yeah. Now hear me?
Yes, yes. Could you please conclude because we have that time?
It's 1 minute more. No problem. And I close to finish. Okay, next slide, please. Okay, here we see that curves dynamic viscosity in the timing. And this is, as I said, the George Souza method. Yeah, but you see the orange, it's in the border. That's 1 in the 5 times. All this one, it's down the line, the black line, it's activated rubber. It looks like activated. One of the, it's analogy of the RAR rubber. It's, I suppose it's something looks like a yellow or blue. Yep. Okay. and it means that we use Zolgel method. It's possible to use to got a numbers, to got a level of the activation. Next slide, please. And what I can say in conclusion, of course, we need more statistic, but what it's possible that I am thinking about certification, I am thinking about more deep definition. What does it mean, activated rubber? Reacted and activated rubber, as George Souza said. I said only activated rubber. And it's old style, probably, I don't know. We need, of course, statistic. This method we are checking only 2 years, but we made some statistic. But probably it can be a very good tools with a very cheap equipment and quite good to use in a statistic and quite good to determine it. Also, now we are working for the mathematical level, for the chemical level, to predict with these numbers, predict the behaviors of the asphalt mix and behaviors of the bitumen mix. Thank you very much. That's for the evening. Have a good evening.
Okay.
Probably the connection is still good.
Okay, thank you, Andre. So, as you can see, we are completely outside of the schedule, so we'll move the question for the reception or for tomorrow dinner or somewhere in lunchtime. So, we pass to the next presentation.
Yeah. Thank you very much. In any case, I understood why it's so, because I don't have a chocolate nearby me, yeah?
Yeah.
Okay. Have a good evening.
Thank you, Andre.
Okay.
Good evening.
Okay, thank you.
Bye-bye.
So, next presentation is a paper about compatible performance of asphalt binder modification using React and activate rubber and develop PAT Rheology Mechanical Sustainability Perspectives, and the paper will be presented by Mafra. Where is Mafra? Here. Okay. Please introduce yourself, and after that you can present the paper. You have 10 minutes, okay?
Okay.
Nice to meet you, everyone. My name is Nailton Mafra. I'm from University of Brasilia, from Brazil, and I'm doing some research about waste disposals like curb rubber and plastic wastes. For today, I will be a presentation some comparative like modification using RA and polyethylene terephthalato modification in asphalt binders. Let's do it. Okay. The context is the traditional asphalt binders have some limitations, include rutting, fatigue cracking, and temperature sensitive. And my research is focused into enhancing binders' performance and promotion environmental stability. The objective is comparing like some rheological, physical, and mechanical sustainability implications for RA and polyethylene terephthalato to modify asphalt binders. About the materials and methodologies, using the base binder, standard asphalt binder classified as PG64S22. For modification levels, I use the PET, polyethylene terephthalate, result for chemical recycling for 2 percentages, 6% and 8% by weight, and there are 25% and 30%. For the preparation, I use the high share mixing at 170 degrees Celsius for sure, and shorten aging simulating using RT-FOT. For the methodology, I do some tests like penetration, stopping point, viscosity, and DSR, like some parameters MSCR and LIS. Some results about the thermal stability is stiffness. All the modified body shows reduced penetration and soften point when compared with the knit binders. That indicate high stiffness, improve the thermal stability. Okay. About the viscosity, the high modified binder displays substantial viscosity increase. This high viscosity correlates with greater stiffness, but requires like technology controls. For PET binders, exhibit the moderate increases in viscosity. For MSCR, both PETs and HAR effectively enhance the viscosity response and reduce rotting susceptibility, and both PET and HAR qualify for heavy traffic recovery categories. About the LIS, both HAR and PMB show the best overall performance, maintain high NEF parameter values across the all strain levels. The main conclusions is performance synthesis. Both HAR and PETs modification strategies successfully improve the base binders. About the PET recommendations, PET binders are more sustainable for hot climates and heavy traffics. About the HAR recommendations, HAR binders offer logical implementation advantages. Finally, sustainability impacts. Both approaches contribute significantly to circular economy. HAR utilizes end-of-life tires, and PET modifications valorize post-consumer plastic waste. That's why.
Okay, thank you. So, due to time, due to time, we moved to the question for the reception or for tomorrow. So, Mafra, please give to Marcio my regards. Last time I met him, he was in Vietnam, in Hanoi airport. So we are at the same place asking for visa. So next presentation will be made by George Way that will talk about Asphalt Rubber's 60 years of people, places, and progress. So, George, place is yours. I think you don't need to introduce yourself.
What do I do?
So, go ahead.
All right, and you got, how do we get out of this thing now? All right, anybody have any suggestions here? In show, that's a good place to start. How do I get to the next show? Here?
Yeah.
All right, and let's see about something here. This thing?
Exactly, yeah.
All right. Well, my presentation's almost finished. That's good. All right, this is going to be short, and I'll make it very short. The point of this presentation really was to honor people in the past who louder,
Yeah.
The point of this presentation is to honor people of the past, and they're not here, so we can skip ahead pretty quick, I guess. But they were all important, and the names are up here: Charles McDonald, Gene Morris, Robert Bob Winters, Don Nielsen, Bernard Barney Valerga. The paper has a lot of really good stuff in it and a great history of this. Kind of hard to take care of that, and it's hard to talk about 50 years of work in 10 minutes. But let me just say there's also some other things here, too. There are support organizations. This organization, Arizona, the Asphalt Rubber Producers Group, is gone. NALBA was very effective. The Rubber Pavement Association, Rubberized Asphalt Foundation, which I'm chairman of, and Council PAL, who has been so great in all of these conferences. These are the conferences, and those are the places. So we've got people, places, and progress. Today, we've been hearing about progress. Maybe just for a minute, we should hear a little bit about people. This is a person. He's passed away long ago. But many people consider him the father of all time of asphalt rubber because of all of his work. He was an early inventor. We talk about inventions. We talk about people. Sometimes we say things need to be sponsored by the government or whatever. These people were sponsored by themselves. They didn't have a big government behind them or some tremendous organization behind them. Most of them were on their own, with one exception. I'll come to that in a minute. You'll note here that this gentleman has 5 U.S. patents and 4 Canadian patents that were issued between 75 and 78, 1975. I would say that's a pretty good accomplishment, for that matter. This is what he looked like later in life, and very active right up to the end, as I understand it. I think he lived probably into his 90s. But in his earlier days, he made little patches. He put them down. He did the work. He made this stuff in his kitchen. He demonstrated it to people. It was crude to place it originally. They didn't really know exactly what to do with this stuff when they tried to go from a little patch to, make a bigger thing out of it. And along came Saguaro Asphalt Petroleum. This gentleman, Bill Brake, who was president, got involved, and they destroyed some distributor trucks in doing this and trying to figure out how to spray this stuff. A lot of this early work was all seal coats. Ken Hill invented brand new equipment. Bearcat came along in 1969, and he invented all new equipment, and that's one of the reasons why it can be spray applied so well, because of his inventions. This very early project was done in 1967 on the Sky Harbor Airport, where they actually put a seal coat on a runway. And I'll come back to that in a little bit. Here's Gene Morris. He had a lot to do with this, a good friend of Charlie's. He sponsored a tremendous number of projects with the Arizona Department of Transportation. His boss was Bill Price, who some people thought he was very much a conservative guy, but actually he was somebody who saw the future, and he put a lot of support behind Gene Morris and research, and I was actually in research at that time. So Bob Winters, he was an inventor also, and a co-inventor with McDonald. He had 2 patents with his own name on it. He put $250,000 of his own money in it between 67 and 74, merely in order to get the patents. It took 7 years to get a patent. So if you think it takes time now to stand in line to get your passport checked, think about 7 years trying to get a patent and $250,000. This is another gentleman, Don Nielsen. His company wound up with 1 patent. And the difference between California's product and Arizona's product was because Arizona basically had asphalt and rubber, also with diluent. His product had asphalt, rubber, extender oil, and natural rubber. And that's a product that's still used in California. The product in Arizona today is asphalt and rubber. There's no diluent anymore. I could say a lot about this guy. He was a tremendously respected engineer in the field of pavement design, pavements in general. And he eventually became, this is a long story and I don't have time to tell it here, but at break, we will get George Souza, who rushed me through this, but he will tell you the story of Barney Valerga to everyone in here while you're drinking. All right. This gentleman was with ARPG, Rush Normeyer. And I'm going to come back to that airfield. He worked underneath Charlie McDonald. He took his place later. And while he was with the city of Phoenix, he actually accumulated all this data. And you will see here asphalt rubber on that seal coat on the runway, hardly aged at all, whereas similar seal coats adjacent to the runway They aged a lot, and that got a lot of attention back in its day when it was published. Later on, the Asphalt Rubber Producers Group became the Rubber Pavement Association. Donna Carlson, the first director, Doug Carlson, who was supposed to be here, but they lost his luggage, and Mark Belshie, who was the last real director of RPA. And now we come to some foundations. Recycled Tire Engineering Research Foundation was first one. I was chairman of it in 2004. I am still chairman of it. I can't get rid of this position, by the way. It's once you are named president, well, president actually too, and chairman, you have to die. That's the only way you can get out of this. So I'm still in there. I'm now also over the Rubberized Asphalt Foundation. These are nonprofits. We don't make any money. But if any of you want to donate money, we will take it. You can donate, you know, and it's, by the way, it's nonprofit, which means it's not taxable in the United States of America. Now, I don't know about foreign countries, but in the U.S., it's a tax write-off, actually. And then there's somebody called George Souza with something called ConsulPav, which we wouldn't be here today if it wasn't for George volunteering in Brussels in 2000 to have a conference the same year in Portugal, and we didn't even know what we were doing. So that was good of him, and we still don't know what we're doing sometimes. Like right now, we're behind, right? So we still don't know what we're doing. Just to close this up, I think Charlie McDonald will be very happy with the situation. We're in Lisbon. We're going to go someplace next. I want to mention these people because they played a role along the way. Howard Cox from Texas, he was a big promoter of asphalt rubber. Richard Stubstead, who passed away many years ago, but he was also a big promoter. Jeff Smith is still alive, and he's active and busy, so he can't be here. He's actually working, and he was at the first conference, but even to this day, he's very, very active. Jord Pai, who is always active, he's always working. I've never seen the guy stop working, but he's done a tremendous amount with asphalt rubber. And Shakir Shatnawi, who both of these gentlemen were at the first conference as well in 2000. And then my old boss, Doug Forresty, Joe Cano, and Stone. I could say a lot about all these people and many, many more, but I'm limited to 10 minutes only. So I think I've come to the end. Thank you.
Thank you, George.
All right.
I'm so sorry, but there's something he said that is not correct, that you are always working, because when you are doing that testing in Arizona, some of us were working and you went to Las Vegas.
Not Las Vegas, to Grand Canyon.
Okay, he said it, okay? He was in Las Vegas, and everybody was doing testing on that.
But he had a bad case of heat stroke that night, and the only way he could stop was to drive all the way to Grand Canyon, which is 250 miles away. But that's
Yeah. Oh, okay. Thank you, George Way, this presentation. Remember, most of these people that make asphalt rubber great again. Oh, sorry. So, next presentation. The title is Unlocking the Potential of Lean in Asphalt Rubber Bind and Attempt to Synergy Bio-Based Industry Waste and Scrap Tires, and will be presented by Renuka Ork, okay, from India. So please introduce yourself and try to keep your presentation within 10 minutes.
Is this on?
Yes. Thank you. Good evening, everyone. I am Harmandeep Kaur from IIT Tirupati, India. Today, I'll be presenting on the topic Unlocking the Potential of Lignin in Asphalt Rubber. It is an attempt to synergize the bio-based industrial waste with end-of-the-life discarded scrap tires. This is our research team, Renuka Bhatt, myself, and Professor Krishna Prapurna Biligiri. Presentation outline is as such. First, we'll start with what is bio-based binders. A bio-based binder is a sustainable alternative to traditional asphalt, which can be derived from all the renewable organic materials. As we know, India is mostly agricultural waste country. Most of the production, most of the economy of India depends on agriculture. And if economy is dependent on agriculture, we are also having excessive agricultural waste, which usually end up into incineration, which cause global warming, climate change, and so forth. So our major motive is to address these two things. First is environmental concerns. We know that fossil fuel depletion is happening. We need an alternative to traditional fossil fuels. And there is another issue, that is we have to address the problem of agricultural waste disposal. So our motive was to utilize and to address both the problems together. So as here we can see that globally 100 metric ton of kraft lignin. Kraft lignin is a end product from the paper and pulp industry, and which can also be obtained from other agricultural products. And here you can see the numbers that only 2% is recovered from material applications, and rest of the 98% is burned for energy recovery. But we can't use the kraft lignin as such in binders because it is very brittle in nature. So we want some binder which can act as a mediator in a way that we can utilize lignin, which is a bio-based product, as well as we increase the properties, we enhance the properties of binder. For doing that, we are utilizing rubber tire, end-of-the-life tires, which we all know that around 1,000 million waste tires are discarded annually, which also end up in landfilling and incineration, and which is hazardous to environment. So our end result was to incorporate the kraft lignin along with the rubber, which will increase the tensile strength and tensile modulus of the binder. This is the research objective, to investigate the compatibility of lignin and AR together in asphalt modification, and to develop a new set of novel lignin modified asphalt rubber binders and mixtures through rheological and mechanical performance assessments. This was the scope of study. So basically, first we took the base binder, which is VG30, and then we incorporated lignin into it, and several issues were there when we are incorporating lignin. To address those, we added some dosages of crumb rubber, ranging from 5% to 20%, and then all the aging binder testing, which included fundamental rheological tests as well as advanced rheological tests, were done to characterize the new set of binders. And then finally, the selected dosages were utilized to prepare the mixtures, and the mixture testing was carried out on those mixtures. These are some of the results and analysis of the binder testing. Here you can see orange color one, that is in all this thing. First one, blue color is only with lignin. Orange one is the 20% replacement of binder with lignin plus asphalt rubber. And green one is only asphalt rubber. We can see in all the dosages, this is like 0%, 5%, 10%, 15%, 20, and 25% of rubber when we are adding. We see the softening point is increasing in all the cases. Similarly, in penetration value test, again we can see that for 20% lignin plus asphalt, it is performing, it is more stiffer than when we are modifying the binder only with lignin. Similarly, in case of advanced DSR testing, we can see at lower temperatures, when we are modifying the binder with kraft lignin and 20% of the crumb rubber, it is performing way better than when it is only with the bio binder. And at higher temperatures, it is having higher complex values. Similarly, when we performed JNR testing, that is for testing the recovery rate of the new binders, here you can see when we are adding almost 20% of the lignin and 20% of crumb rubber in binder, it is performing almost 1.5 times better than without modification or with only lignin modifications. In non-recoverable creep, JNR value is way lower for the modified binder as compared to the unmodified binder, and also for only bio-based binder. And this was the radar chart that was prepared using all the results from different binder testing. And on the basis of the area of this radar chart, we came up with the composition that is KAR 2020, which means 20% of kraft lignin plus 20% of rubber if it is added in binder. Then almost the distance from the virgin binder was 3.01, and it ranked 1 according to all the testing. And then further testing was to give more substance to the testing. Mixtures were tested using these dosages, and various tests were performed. Here also we can see for TSR, mainly 3 major tests were performed. One for testing the moisture susceptibility. In this case, it is TSR test. And here we can see for crumb rubber, values are higher than 0.8. And for crumb rubber plus lignin modified mixture, it is almost 0.9 or beyond 0.9. That is, the mixture is very much resistant to moisture. Next, for testing fracture performance was tested at 2 temperatures, one at 25 degrees Celsius and at minus 20 degrees Celsius. In both the cases, we can see for CRL, that is combination of both lignin and crumb rubber, energy, fracture energy is way higher than if we are testing the material which is having only lignin in it. Next, these are the results of like when we are testing the fatigue cycles. In this case also, you can see for the mixture which was having both crumb rubber and lignin, it is almost twice as compared to when we are utilizing only lignin or only bio-based binder in a mixture. These are the conclusions and recommendations based on the binder testing as well as the mixture testing. From advanced geological characterization, we can conclude that it improved the elastic recovery, which initially with biobinder we were facing problems. Those problems were solved when we are adding almost 15 to 20% of crumb rubber in the modified binder. And binder selection for further testing was K20, that is 20% dosage of lignin and 20 to 15% of AR. And in advanced mixture characterization, for retting performance, it was observed that lignin crumb rubber mixture performed way higher than the conventional binder and the biobinders alone. And in fatigue performance also, the modification of 20% lignin in combination with 15 to 20% of crumb rubber gave almost 1.2 to 1.5 times the conventional mixture. And for further recommendations, lignin plus crumb rubber can effectively be utilized for enhancing the aging and to improve the retting and fatigue performance of the mixture. And lignin should be limited to 20% of the modified binder and to avoid the crystallization. Thank you. And these are the key takeaways, that for every 100 ton of virgin binder, about 30 to 35 tons of the binder can be replaced using crumb rubber and the lignin, from which we can say that this 35 tons of lignin which can be utilized to replace 100 tons of virgin binder, almost 2,000 tons of sludge can be removed from the waste paper industry, which is, in this case, lignin will act as an antioxidant. And on the other hand, almost for 100 tons of virgin binder, we'll be utilizing 5,000 waste tires, which can be replaced from landfilling and can be diverted to waste to wealth, like it can be utilized in a better way, and to increase the performance of the binder. And I extend my acknowledgements to Tina Rubber for sponsoring this project and for providing us material, and IIT Tirupati Laboratories for all the performance tests and characterization of the materials. Thank you.
Okay, thank you. And last presentation, after a long day, is a paper about cutting costs, cutting carbon, building tomorrow economics and environment benefits of LPG and natural gas in asphalt production. Will be presented by Luís Vieira, or for both? Oh, perfect.
I am very sorry. They're going to be speaking Portuguese, and then I'll kind of... who doesn't understand Portuguese? Who does not understand Portuguese?
I understand.
Okay, I'll translate for you if they say anything interesting. Não, foi no final.
Sentes-te ali, está de lá. Não, sentes-te ali. Bem, boa tarde. We will the presentation in Portuguese, like Jorge, and in the end, Jorge will make a short summary for those who did understand. Em primeiro lugar, eu quero agradecer ao Jorge, quero agradecer ao Asphalt Rubber, que há... sim, já lá vou. Isto também é para agradecer, não é preciso. Quero agradecer ao Jorge, ao Asphalt Rubber, e parece que foi ontem, mas foi há 25 anos, em Vila Moura, no Marino Hotel Tivoli, que houve a primeira em Portugal, e eu tive o prazer de lá estar e de acompanhar toda a evolução destas conferências e todo o trabalho que o Jorge e o querido Paulo também fez nesta área dos asfaltos. A nossa apresentação é basicamente para refletirmos todos um bocadinho, para pensarmos que estamos aqui a falar, e fala-se muito em termos de aditivos e aditivarmos o betume para diminuir a viscosidade do betume, ou para modificar a viscosidade do betume, para trabalhar a baixas temperaturas, sem conhecermos muitas vezes, pelo menos eu não conheço, todos os problemas ou o que é que esses aditivos vão provocar nos betumes. Não sabemos. E o que nós vamos aqui tentar passar a mensagem é realmente, com certeza, ou menos, a mensagem que vamos aqui tentar passar é que existem energias alternativas que nos fazem, ou que emitem menos CO2 e que não custam mais caro que o que temos. Portanto, é isso que eu vos queria dizer. Eu também passei por aqui já noutra organização, e agora estou num grupo que é o Alves Bandeira, e trouxe-vos só aqui 2 ou 3 slides para vos explicar, mas como só tenho 10 minutos, vamos começar. Bem, falar aqui um bocadinho da sustentabilidade, e nós falamos todos muito de sustentabilidade e andamos todos a falar de sustentabilidade, mas se não tivermos três vetores: sustentabilidade social, económica e social, ambiental, económica e social. Portanto, estamos todos a olhar para a sustentabilidade da nossa quinta. Portanto, eu tenho um carro elétrico, não emito. Eu tenho os painéis solares, portanto, ou conjugamos as três coisas, ou então é difícil e não existe sustentabilidade, porque olhamos todos para o nosso umbigo. Eu sou sustentável porque faço isto. Portanto, e esquecemos tudo o que está e o ciclo todo. Portanto, eu às vezes ouço muita gente a falar de sustentabilidade e, sinceramente, acho que grande parte não sabe o que é sustentabilidade ou não quer saber o que é sustentabilidade, porque a sustentabilidade, ou temos os três vetores ou não existe sustentabilidade em lado nenhum. Portanto, ou temos sustentabilidade ambiental, a sustentabilidade económica e, importante também, sustentabilidade social. Portanto, se não houver sustentabilidade social, portanto, isto também... Portanto, os três vetores da sustentabilidade é que, efetivamente, fazem sustentabilidade. Porque, por exemplo, nós temos em Portugal, um exemplo mais da nossa área de obras públicas, temos uma obra em Viana do Castelo e o dono de obra só quer um agregado que a forma XPTO. Mas o Ministério do Ambiente não deixa abrir mais uma pedreira naquele local. Então, aquele senhor vai buscar agregados a 200 km. Portanto, houve alguém que cumpriu o seu papel de sustentabilidade, mas em termos de sustentabilidade global não existe. E o que nós fomos aqui fazer, e com a Tecnovia depois vai reforçar aqui esta parte, foi comparar diferentes fontes de energia na produção de misturas bituminosas numa central para produzir misturas bituminosas num determinado cliente. E comparámos fuel, gasóleo de aquecimento, GPL e gás natural. E as conclusões que vamos chegar, e aqui é muito teórico, e o Pedro depois vai apresentar a parte mais, a realidade factual, é que o que nós vemos aqui é que comparamos os PCIs, o poder calórico inferior, as emissões de CO2 por quilograma queimada e o que é que emitimos em termos de CO2 e, por fim, o custo euro tonelada de cada combustível. E se verificarem o custo do combustível mais usado nas centrais de misturas bituminosas, hoje em dia é o fuel, e é o custo mais barato. E o mais caro anda ali o gasóleo de aquecimento a par com o GPL. Portanto, qualquer decisor num empreiteiro olha para estes valores e diz, nem quero ouvir falar em mais nada porque o mais barato é o fuel. E a razão que nós, das 150 centrais de produção de misturas bituminosas que temos em Portugal, apenas 16%, repito, 16% estão a trabalhar a gás. Portanto, todas as outras estão a trabalhar a fuel. Porquê? Porque, e se vamos olhar para outro tipo de empresas, onde tem já procurement, supplies, já olham para isto de outra maneira. O empresário, o empreiteiro português, infelizmente ainda não está muito para aqui virado e olha, custo unitário 800, o outro é 1000, portanto é este dos 800 e acabou. Mas se formos ver, eu para gerar, em termos de emissões de carbono, eu para gerar a mesma energia, ou seja, eu para gerar a mesma energia, com 400 toneladas de fuel, eu vou emitir 14.300 quilos de CO2. Ou seja, o fuel é o que me vai emitir mais CO2 e de uma forma clara, quase o dobro, não é o dobro, mas é quase o dobro do gás natural. Em termos gráficos, ainda conseguimos perceber melhor. Em termos económicos, e aqui eu peço atenção, porque o que vemos aqui, efetivamente, é que eu, com 400 toneladas de fuel, que me custa 870 euros, vou gastar 348 mil euros por ano. Com gasóleo de aquecimento eu já não vou gastar 400 toneladas, vou gastar 421, o que me vai custar 400 mil euros por ano. Com o GPL eu passo para 344, para gerar a mesma quantidade de energia, e para gerar a mesma quantidade de energia com gás natural eu vou gastar 334 mil euros. Portanto, e vocês dizem, isso é tudo muito bonito, porque isso é teórico, isso é matemática, isso é isto, é aquilo. Não, o Pedro a seguir vai demonstrar que ele produz a gás e produz a fuel, e todos os dias produz, e o Pedro vai-vos demonstrar que eu não preciso estar a aditivar betumes, se eu aditivar melhor, porque aí ainda gasto menos. Mas, portanto, basta mudar a minha fonte de energia que eu tenho na produção da mistura bituminosa, que eu de alguma forma reduzo as emissões de CO2 e reduzo a minha fatura ao final do ano na produção da mistura bituminosa. Portanto, o que nós vemos aqui é que o gás natural oferece um menor custo e menores emissões de CO2, é a conclusão que nós facilmente chegamos, entre os combustíveis que comparamos. O GPL apresenta um custo e emissões ligeiramente mais elevadas que o gás natural, mas é mais eficiente e mais limpo que o gasóleo de aquecimento e o fuel. Em termos de gasóleo de aquecimento, é o que apresenta o maior custo e o maior em termos de emissões, é também o que emite mais é o gasóleo de aquecimento. Portanto, torna a opção menos favorável do ponto de vista ambiental. Em termos de sustentabilidade, a mudança para combustíveis mais limpos na produção de misturas bituminosas vai incrementar a viabilidade económica, a sustentabilidade ambiental e social na produção de misturas bituminosas. E para concluir, o Pedro depois é mais rápido que eu, o gás natural e o GPL reduzem efetivamente as emissões de CO2, ajudando na mitigação das alterações climáticas e no cumprimento das normas ambientais, tanto atuais como futuras. Em termos económicos, menores custos operacionais, maior eficiência energética levam à redução de custos de produção e um melhor aproveitamento dos recursos. E em termos sociais, ou seja, os combustíveis mais limpos vão promover locais de trabalho mais seguros, gente mais motivada, gente mais feliz. Portanto, de alguma forma nós conseguimos aqui, com a alteração da fonte de energia, bater nos 3 vetores da sustentabilidade e reduzir a fatura e reduzir as emissões. Pedro.
Boa tarde a todos. Também em nome da Tecnovia e em meu nome agradecer aqui ao Jorge Sousa a nossa presença aqui neste congresso. Não temos 25 anos de experiência, mas em 2017 tivemos cá fazer aqui uma pavimentação com raio-x, que não correu assim muito bem, mas é a história que nós temos. Começando do princípio, só para falar da sustentabilidade, que no fundo, o que é sustentabilidade, que é a capacidade de satisfazer as necessidades de hoje, sem comprometer as nossas gerações futuras. E numa indústria como a nossa do asfalto, que tem um peso muito grande na sustentabilidade, é um fator, no fundo, de competitividade e de sobrevivência para a nossa própria indústria. E o que é sustentabilidade? Nós podemos medir a sustentabilidade, porque o que se mede podemos melhorar, ou o que não se mede não se pode melhorar. E a sustentabilidade deve ser a base para decisões fundamentais de economia circular e desempenho ambiental. E ao mensurarmos a sustentabilidade, podemos garantir a comparabilidade e a transparência das várias soluções que existem no mercado. E é uma forma de nós fazermos mensurar a sustentabilidade, é nós termos as DAPs ou as EPDs para nós conseguirmos comparar as várias soluções que nós temos de asfalto no mercado. Portanto, a Tecnovia é a primeira empresa em Portugal a ter as EPDs, as DAPs verificadas e emitidas, de misturas bituminosas e de agregados. Portanto, nós temos atualmente 13 DAPs verificadas no EPD Hub, de camadas de base com e sem fresado, camadas de desgaste com e sem fresado, misturas temperadas e também de agregados em 400 industriais. E, portanto, as nossas EPDs, as nossas DAPs da indústria apenas focam a matéria-prima, a produção e o end life e o recovery do life cycle da EPD. Portanto, nada de construção nem do uso da própria matéria-prima. Portanto, em termos industriais, é apenas do produto que nós estamos a produzir. E em termos de resultados, em termos de sustentabilidade ambiental, nós podemos concluir, de acordo com os dados que nós temos das nossas DAPs, em que para uma mistura de camada de desgaste com a utilização de fuel para a utilização de GPL, temos uma redução de 44% apenas por trocar o combustível de uma central de fuel para uma central a GPL. E quando falo de fuel obviamente é o fuel, o gasóleo de aquecimento, neste caso tem biomassa, portanto destilha, para troca da sua totalidade por GPL, em que a queima e o aquecimento do betume passa a ser a GPL. Portanto, temos uma redução de 44% apenas por mudarmos o combustível. E como estamos a falar em termos de sustentabilidade, e porque penso que é algo que é importante, nós também falamos sobre isso, nas misturas temperadas, a gás, nós temos uma redução de 62% face a uma mistura tradicional de misturas de desgaste sem fresado, também a fuel. Portanto, são duas formas muito significativas, são duas formas onde nós podemos ter uma redução muito significativa da pegada de carbono. Portanto, isto são números que estão certificados e estão, neste caso, verificados pelo EPDAB. Em termos de custos, e fazendo a comparação da central que nós temos em Ourique, o custo real que nós tivemos em 2024 com combustíveis foi 262 mil euros, e se nós estivéssemos a utilizar GPL, nós efetivamente gastaríamos mais ou menos a mesma quantidade de dinheiro para fazer essa produção, portanto teríamos 1% mais caro, mas se utilizássemos o gás natural na mesma instalação para fazer este trabalho, tínhamos uma redução de 15%. Mas tendo em conta que os preços dos combustíveis são extremamente variáveis, eu fiz esta simulação, portanto fiz isto a preço de julho deste ano, e que nós efetivamente aqui com os preços que estão do mercado, tanto dos combustíveis fuel, biomassa, gás natural, gasóleo de aquecimento e GPL, passávamos a ter uma redução significativa, tanto do GPL como do gás natural para a produção de misturas bituminosas. E, portanto, nós quando fazemos aqui esta comparação entre gás natural, ou GPL e fuel, eu não tenho diferenciação entre gás natural e GPL, porque as nossas contas são com GPL apenas. Nós acabamos por ter um melhor desempenho ambiental, portanto, temos uma redução de CO2 das misturas. Temos obviamente, por estar a utilizar gás, nós não vamos ter derrames na central, que é algo que vai limitar e vai diminuir essa possibilidade de derrames, portanto, acabamos por ter também um melhor desempenho ambiental. Em termos económicos, eu vou dizer que temos uma redução de custos, apesar de podermos não ter e ser pelo menos um preço direto por tonelada produzida similar ao fuel, mas obviamente em termos económicos e desempenho da mistura deixamos de ter problemas daqueles riscos que de vez em quando nós temos uma queima ineficiente do fuel e passa algum fuel para a mistura bituminosa, e no fundo também temos uma muito maior vida útil do filtro de mangas da própria central, por utilização de gás e não utilização de fuel. E, portanto, no fundo, são vantagens ambientais e económicas que nós temos por a troca, no fundo, de fuel por gás natural. Obrigado.
É só para traduzir.
Ok, está bem.
Just a small translation. Basically, they are trying to tell us that if you change the fuel to natural gas, the environmental benefits at basically the same cost, and sometimes the benefits are huge. Meaning, we should change the plants from diesel, fuel oil to natural gas. You already get huge benefits in CO2 emissions. Okay, this is so huge that I wonder why there's no mandate from the government to make these changes. What they are saying is, oh, we have to be environmental benefit, we have to lower the temperature of production, which is a small thing compared to the big thing you can just do by changing from from fuel to natural gas. LPG, sorry, and LPG, natural gas, LPG.
No, natural gas and LPG.
Natural gas and LPG, okay? So, sometimes you understand the political pressures to go this and reduce the temperature, and then they say, okay, we can put many things just put butter to lower the viscosity. I don't know. What is butter going to do 10 years from now? Nobody did that research, but we have to lower it now. They are saying that if we really need to save CO2, it's better to just mandate everybody to change to LPG or natural gas. And natural gas. Okay. So now,
Okay. Give me one second. So thank you, Luis, and I forgot your name. With this presentation, we conclude this section. So we had 5 interesting papers, and please join me in knowledge for all authors.
So now,
George Souza explain the remaining
it's
part
very,
of the
very
day.
easy now. You stand up, walk, make a left turn, and ask for a drink. Reception time. Have a lot of good drinks, I hope, and old vintage port wine, 20 years old, Tawny, very selected, some gin and tonics,
Wow, fantastic.
some
Wow.
jamón from Spain. So enjoy, let's have fun.
Okay, thank you.